So far as I am able to judge, nothing has been left undone, either by man or nature, to make India the most extraordinary country that the sun visits on his round. The Indian way of life reflects its ancient wisdom, and Indian systems of knowledge continue to provide sustenance to its people. One such system is Ayurveda, the science of life. An attempt is made in this series to present the therapeutic and other procedures enshrined in Ayurveda, to treat a variety of diseases and to promote healthy living.
Hello, doctor.
Hello.
I was just scanning through this journal. It says that there has been a rapid increase in the incidence of asthma in recent years in India. About 2,500 people per lakh of population are affected by asthma in our country. Prevalence of this disease is seen more in the rural areas than in the urban areas. Percentage-wise, more males are affected by this than females. We have with us today Dr. Murli Manohar, who is going to educate us a little more about asthma. Doctor, what exactly is asthma?
Asthma is characterized by three main symptoms basically. First one is the well-known symptom, that is breathlessness. Second one is the cough. This is a little bit not known to the public. And third most important symptom will be the bronchial wheeze. Asthma results due to the narrowing of airways, especially bronchioles in the lungs. And expirational wheeze is the characteristic feature of bronchial asthma. That means there will be a sound while breathing out. This is the most important thing in bronchial asthma.
What are the variations of asthma?
Yes. Asthma can be divided into two main groups, extrinsic and intrinsic. Extrinsic asthma results due to the external influences, mostly like allopathic drugs and certain food items and fur and feathers. These things can aggravate the extrinsic asthma. And mostly these dust mites or house mites, they are the leading causes for this asthma. And certain types of pollens also, like pollen from Congress grass. These things will aggravate the extrinsic asthma. And it is mostly seen in young individuals, those who have sensitivities and those who are allergic to certain types of substances.
Are these familial tendencies?
Yes, especially extrinsic asthma has got this familial tendency. That means there is a possibility of hereditary origin also in this.
What do you mean by intrinsic asthma?
Intrinsic asthma results due to the internal influencing factors. It is nothing to do with allergies or familial tendencies. In most of the cases, it is seen in older individuals, especially those who are suffering from chronic bronchitis or bronchial infections, or those who do the physical exertion a lot, and those who are suffering from anxiety, depression. In these individuals, there is a possibility of intrinsic asthma.
What does Ayurveda say about asthma?
Ayurveda has grouped different types of diseases, especially 5 diseases, into a single rubric with the name Svasa. And Tamakasvasa is one among these diseases. The word tamas means inertia or darkness. As there is a possibility of decreased air into the air supply into the body, there is a possibility of inertia or darkness in the mind. Hence the name Tamakasvasa.
What is the Ayurvedic treatment for bronchial asthma?
Ayurveda always emphasizes on combination therapy that consists of mainly drug therapy, diet therapy and lifestyle modifications.
Can you explain what is diet therapy?
There are certain do's and don'ts in Ayurveda as far as bronchial asthma is concerned. What to eat and what not to is important as far as the diet is concerned. Do's are called patya in Ayurveda and don'ts are called apatya in Ayurveda.
Can you please explain briefly what is patya?
Patya means which are beneficial to bodily channels like rasa, rakta, mamsa, medus. And apatya means which are harmful to the bodily channels.
What are the different ingredients that are part of patya?
We can include or try to take these substances in excess, like hot and pungent substances like chilies and peppers. They have got that bronchodilating effect. And strong substances like onion and garlic, they are helpful in bronchial asthma. And certain food supplements like cow ghee, which has got the toning effect of the muscles, you can take it liberally. And especially certain food items like coffee, they act as a bronchodilators. So you can use these substances also in moderation. And mostly the most important thing is old rice and goat milk. These are specially emphasized in Ayurveda, especially in bronchial asthma. Because old rice, it can be easily digested, and digestion is very important in bronchial asthma. Because it was said as Tamaketu Virechanam. That means in Tamakasvasa, that is in bronchial asthma, Virechana should be done, that is purgation should be done, or at least digestion should be regular. And coming to the goat's milk, it has got the strengthening effect of the respiratory muscles.
What do you mean by apatya, and what are the different ingredients that are included in apatya?
There are many more food items that are included in apatya, or which are not beneficial to the body, especially allergy producing foods like eggs. Eggs are the major allergens, and in the same way nuts, especially ground nuts, they are the allergens, and fish is the major culprit. You have to avoid it. In the same way, as a matter of fact, all animal foods are not good for the health as far as the asthma is concerned. And certain types of artificial additives like sodium monoglutamate, MSG, this is the main culprit. And mucus producing foods also should be avoided, like milk is a mucus producing food, curd is a mucus producing food, in the same way banana, and most of the sweets, they produce mucus. So this mucus will block the channels or bronchioles, and as a result bronchial asthma will be triggered. So these things should be avoided or at least minimized.
What are the deeds and lifestyle modifications suggested by Ayurveda to control asthma?
This modality is important because it is called as vihara. So we should be choosy or selective as far as our lifestyle modifications are concerned. Try to identify the cause and avoid it. This is the basic rule. In most of the cases, allopathic medicines are the culprits, especially non-steroidal anti-inflammatory drugs, beta blockers, aspirin like drugs. These will constrict the bronchioles. As a result, bronchial asthma will be resulted. That's why try to avoid these allopathic drugs, and try to stay away from the allergens, especially from the dust and vehicle pollution, smoke, certain types of strong perfumes and odors, animal dander, fur. You have to stay away from these allergens. This is basically important. And most important thing that Ayurveda has advised is not to suppress the natural urges like urination, thirst, erectations. These things should not be suppressed at all. So you should be very regular as far as the natural urges is concerned. And most important thing is you should not expose to sudden variations in temperature and weather. So this will cause the bronchial asthma due to the unusual bronchoconstrictions. And as far as the house dust is concerned, because we have been discussing that this is the main culprit, try to use vacuum cleaners, or at least you can you can just soak the floor and you can clean with the cloth, but you should not use any broomsticks or any dusting things.
Is there any specific posture that is prescribed to control asthma?
Because asthma aggravates in lying down position, whenever you feel that tightness in the chest, immediately sit straight, or at least try to put your face on your legs. And first of all, you should not be in a tense position or tense mood. If you relax, your bronchial muscles will be relaxed. That's why try to relax and sit straight on the bed and take deep inhalations.
Are there any different kinds of oils that are used to cure asthma?
Because this is due to bronchoconstriction or tightening of the chest muscles, we have to relax it. This is the basic aim. That's why whenever you are feeling the tightness in the chest, immediately you dip some towel or cotton cloth in hot water and spread it on the chest. And this is a type of fermentation. Or else you can apply some Chandanabala Lakshadi Thailam. This is an Ayurvedic medicine. You just spread it evenly and rub gently. This will produce some heat and this will give some soothing effect also. Alternately, you can mix Saindhavadi Thailam with mustard oil. These two are specially beneficial in bronchial asthma. You just mix them and apply externally and give a mild massage, and that will take care about the episodes. And especially as we have been discussing about the dust, pillows are the major culprits, especially these feather and cotton pillows. They attract the dust. As a result, this will be aggravated. That's why try to cover it with plastic covers, or you can it should be well covered. So this is the important thing.
Any yoga asanas or any breathing exercises that
Yes.
help in curing this?
Pranayama is especially beneficial in this, because in bronchial asthma we use accessory muscles also. So to strengthen these muscles so that we will be breathing it freely, pranayama is always advised. You can learn it from any good institution and you can practice it.
Pollution, it seems, is a very big cause that leads to asthma. What do you think about this?
Yes, bronchial asthma aggravates mainly with the pollution. This is the leading cause for bronchial asthma. That's why you can notice many more cases rising as far as the pollution is concerned. Try to stay away from the pollution. If it is inevitable, try to cover your nose as well as mouth with a scarf. This will protect you from pollution as well as cold weather also. So this is always you should keep in mind.
What are the Ayurvedic remedies that are used to control or cure asthma?
There are many more remedies which are mentioned in Ayurveda. To start with, during an acute attack, just express half spoon of juice from the garlic. You can express it from 2 or 3 pots. Mix with hot water and drink it. This will give you instant relief. Alternately, you can express juice from Solanum surrectans.
What is the colloquial name or the Hindi or Telugu name?
It is
for
called
this?
Chote Kateri in Hindi and Nalavakudu in Telugu. You can just express juice from from the whole plant and mix with trikatu powder. You can take just a pinch of trikatu powder. This contains long pepper, black pepper and dried ginger in equal parts. This is called trikatu powder.
Is it equally available easily in the
Yes,
market?
because trikatu means three pungent substances like black pepper and this long pepper. It is called pipali in Sanskrit, and dried ginger. This is a most commonly available substance. These 3 things you just mix in equal parts. Take a pinch of this powder, mix with the expressed juice of this Solanum surrectans, and take it internally. This will give you the relief. And powder of Ephedra vulgaris. This is Somalata in Sanskrit, and this is specially beneficial in bronchial asthma. It has got that capacity to dilate the bronchioles. That's why it has been exported to foreign countries also, from which ephedrine will be extracted from it. But it is always advised to take this herb in raw form instead of ephedrine. So if you just can take with, either you can take with jaggery or you can take as it is with honey, 2 to 3 grams will be sufficient. And if you want to use any classical Ayurvedic preparation which is made from this Somalata, Somaso is the most famous drug. This is available in a liquid form. You can take 4 teaspoons of this, mix with warm water and drink it 2 times a day.
Any kind of oils that help in curing asthma?
Yes, mustard oil is especially beneficial in this bronchial asthma. Take 1 teaspoon of mustard oil, mix with jaggery and make it a paste and take it internally. This will take care.
What are the medicines that are prescribed by Ayurveda to control or cure asthma?
There is an extensive list, but to name a few, as we are saying, Somaso is the good remedy for this bronchial asthma, and Swasa Chintamani, this is a rasa preparation. This is especially beneficial in bronchial asthma, but it should be taken under a medical supervision, especially under supervision of an Ayurvedic doctor. And there are other types of medicines like Swasa Kutar Ras and Chavan Pras, Agastya Haritaki Rasayan. These are the different drugs which are specially beneficial in bronchial asthma. And apart from these things, Panchakarma is beneficial. Panchakarma is a process of eliminating the impurities from the body. And as it is mentioned as a Pitta disorder, mainly Tamaketu Virechanam, that means bronchial asthma is mainly a Pitta disorder. That's why we have to eliminate the Pitta from the body. For that, Virechana is indicated, that means purgation. This is one of the process in Panchakarma. And apart from that, in mild cases, Vamana, that is emesis also is indicated. If you do these purification therapies, then if you opt for this pacification therapies, then you will get the everlasting result.
Do these medicines need to be taken under medical supervision?
Yes, that is primarily important, because as we are discussing, breathlessness is the predominant feature in bronchial asthma, but in other conditions also the same can be resulted. That's why professional monitoring is always necessary to diagnose the disease and to monitor the individual dosage. This is always important.
Is there any complete cure for asthma through Ayurveda?
Yapya stamaka swasa, says Ayurveda. That means bronchial asthma is a complex disorder, especially of the chronic nature, which needs continuous monitoring and individual supervision. That's why lifetime management is necessary as far as the bronchial asthma is concerned, especially if it is of chronic nature.
So you mean to say that it can be controlled but not cured completely?
It can be cured provided if it is purely of allergic origin.
Okay.
That's what we have been discussing. No, there are 2 types of bronchial asthma, extrinsic and intrinsic. If it is extrinsic and if it is with a recent origin, then we can cure it.
Thank you, doctor, for sharing your knowledge about asthma with us today.
Thank you.
I'm sure all of us are more enlightened about asthma. If you have any further queries, please feel free to write to us at Director, Emmrc CIEFL, Hyderabad 500007, or email us at emrchyd@netlinks.com. Thank you.
welcome to the session on citizen journalism, concept, challenges and ethical aspects. We live in a world that is connected and communicated with technology. Today, technology is playing a pivotal role in many streams. It has drastically changed the way we pursue information, communicate messages and interact with others. These technological revolutions drastically changed the media and affected journalism for both the journalist and the audience. Gone are the days when newspapers and televisions were the only source of information. Now, we live in a world where news is updated 24/7 not only by professional journalists but also by citizens, viewers and the audience at large. This news way of audience participation developed the concept and practice of citizen journalism, transforming traditional news format. The introduction of citizen journalism has given ordinary citizens opportunities to become part of a global community by providing instantaneous news using a variety of media. Citizen journalism is a hot topic at present, but there remains a degree of conceptual wooliness about its definition and meaning. This chapter will identify factors underpinning the emergence of citizen journalism, including the rise of Web 2.0. News websites hosted by the major media companies are now competing sources of news. These exist alongside alternative news sources on the internet like websites featuring user-generated content, blogs, social networking sites, and wikis which are gaining momentum. Like mainstream media, these sites offer a wide variety of news. The difference is that the news articles are contributed by audiences or users. The stories range from original reporting of local events and disasters to commentary on entertainment and news stories appearing in mainstream media elsewhere. Therefore, at present, a number of television channels, news portals and blog sites across the globe offer common masses a platform to be citizen journalists and share their stories with the rest of the world. This trend is growing and we see a rise in citizen journalists actively participating and airing more and more issues concerning the masses. Sometimes the best footage of an event was taken on an average person's mobile phone and uploaded to the social network within seconds. What is citizen journalism? We can find many different definitions for citizen journalism. Citizen journalism is the process of gathering, writing, editing and distributing news and information by people not trained as professional journalists. It is a kind of journalism in which the users or audience create content online rather than wait to be fed by the traditional media outlets. According to Serena Carpenter, a citizen journalist can be described as an individual who intends to publish information meant to benefit a community. Citizen journalist has been described as an individual who plays an active role in the process of collecting, reporting, analyzing and disseminating news and information. Citizen journalism is also known as public or participatory journalism or democratic journalism. Though there is no unanimity and agreement on the name of this method of collecting, analyzing and disseminating news by the citizenry for the general public, it is to be noted that its practice has increased over the last decade. And like the traditional journalism, it aims to inform and educate, hold people and authority to account, document and interpret development and changes. Citizen journalism is useful to society at two levels. While on one hand, it educates and informs the society, but on the other hand, it gives them the opportunity to tell and report their stories. Educating and informing the public. Citizen journalism has particularly played an important role of educating and informing the population and the outside world on the social protest during the Arab Spring when foreign media were banned from reporting. Indeed, blogs, Twitter, Facebook, YouTube and other internet-based social networks and digital interactive media users have been leakage holes of information from a hermeneutically closed Arabic world shaken by political unrest and mass protests. Members of the public through internet organized rallies and mobilized resources that led to the fall of political figures including Presidents Hosni Mubarak of Egypt and Colonel Muammar Gaddafi of Libya. In their respective blog posts, Facebook or Twitter messages, not only did citizen journalists update, therefore inform others on the movement, but also educated them on security methods. Through these examples, citizen journalism has shown its necessity of being, its relevance in the current society, and the important role it plays in informing and educating. By sharing their experiences, hence engaging in citizen journalism, members of the public not only educate fellow citizens but also help governments and private institutions in policy making. What other role could citizen journalism play in the society? Platform to speak. Besides being a source of information and education, citizen journalism helps members of the public voice their views and tell their stories. The considerable number of community blogs, Twitter, Facebook and YouTube accounts flourishing daily on internet serve as example. On the fight in Syria and particularly in Aleppo, even though professional journalists were reporting, bloggers had their stories to tell. With the type of journalism in question, one can notice there is a huge variety of a source of information. Indeed, it is now possible to fetch news outside of established agencies like Reuters, Agence France Presse, and even public relations officer and police press releases. By giving alternative sources such as community bloggers, eyewitnesses, and members of the public a chance to report stories, it equally gives them the opportunity to speak for themselves and give alternative storyline. Beginning of citizen journalism. When the world's first website, info.cern.ch, was launched in 1991 by physicist Tim Berners-Lee, it offered no audience interactivity. As the number of websites increased and as the internet grew over the years, new features on websites made it easier for audience to interact with the other audiences or with website publishers. Real change did not come until 2004 when the newly introduced Web 2.0 platform introduced a lot of the features that enabled consumers or ordinary people to publish their own websites or web blogs or feed content into the mainstream media. The combination of Web 2.0 features and digital technologies like digital cameras or video camcorders and camera-enabled mobile phones made it easy to gather and capture video and photographs and post them online. In some ways, this slowly marked the beginning of audience participation in online media. The phenomenon of contributing content to the media seems to be growing and also defining itself. Commonly referred to as citizen journalism, the phenomenon is also known by other terms such as amateur journalism or participatory journalism. Growth of citizen journalism. Audiences are increasingly creating content and publishing it themselves or contributing it to the media rather than just consuming it, as has almost always been the case. Debates on the impact of this trend on mainstream media are widely contested. Some see these audiences playing a larger role in providing news content to the media, perhaps not along the lines of the Korean site Oh My News, which publishes content mostly from citizen journalists, but by being the eyes and ears of the media and providing instant accounts like photographs and videos of incidents, in other words, hard news reporting. Citizen journalism can in one sense be defined by some of its more conspicuous examples. The Korean Oh My News site, english.ohmynews.com, which was established in 2000, has as its slogan, "Every citizen is a reporter," and accesses only 20% of the content for its online site from its employed staff, with the balance coming from the estimated 50,000 South Koreans who post news stories onto the site. One other major focus of citizen journalism is opinion. There are now many forums and blogs where audiences discuss, analyze and do postmortems of stories appearing in the media or discuss politics, the ins and outs of government or economic policy, or simply express raw personal opinions. Some of them are random, but others consistently perform these functions and articulate issues in a synthesized way. citizen journalism has played an increasing role in the reporting of major global events and provides on-the-street accounts of events unfolding around the world, such as the Arab Spring, the Japanese earthquake, and Occupy movements. However, many criticize citizen journalism and say there is high potential for false news being published online. Who are citizen journalists? Citizen journalists are ordinary people who do not necessarily have journalistic training, yet they feel the duty and responsibility to participate in the journalistic process. Just as professional journalists, they seek to facilitate a better society and world by presenting and speaking truth to power. They seek to answer the call of social responsibility. The term citizen journalist did not exist before the advent of the internet. Citizen journalism grew in tandem with the growth of the interactive functions on the internet. Although it encompasses many aspects and comes in different forms like blogs, forums, uploading photographs or videos to the media, citizen journalism has one fundamental basis. The most notable citizen journalism success story is South Korea's online news, Oh My News, founded in 2000 with the motto, "Every citizen is a reporter." The newspaper's open source business model is to accept, edit, and publish articles from its readers. Citizen journalism, impacts and ethical concern. Citizen journalism's practices differ markedly from those of the mainstream news industry. However, the concept of citizen journalism has expanded in recent years to include not only content creation for formal online outlets such as blogs or independent websites, but also citizens' follow-up participation in the news process such as social media posting, reposting, linking, tagging, commenting, and rating. The question of the boundaries of citizen journalism is related to questions about new forms and practices of news production in the digital age. In the traditional news production setting, news outlets have produced via the routines of gatekeeping, selecting, writing, editing, positioning, scheduling, repeating, and otherwise massaging of information. However, in a digital news production context, customary boundaries of news producers and news consumers are blurred, and technically anyone can engage in news production and distribution. This increases uncertainty about journalists' roles. Impacts of citizen journalism. You may ask yourself why there is such a strong emphasis on citizen journalism. From mobile apps to traditional media companies, it appears that everyone is supporting this media sharing platform. Citizen journalism has both positive and negative impacts. Positive impacts are: citizen journalism gives power to the people. Citizens are able to provide raw, real-life material that can never be filtered, and people have the choice of what content they want to receive. It also allows marginalized people to reclaim their voices, to tell their otherwise silent stories firsthand, which would have rarely occurred in the past 10 years. We have seen how this can be true. In 2010 and 2011, hundreds of videos and photographs surfaced just as the conflicts in the Middle East and North Africa were gaining momentum. These videos came from ordinary sons, daughters, mothers, and fathers experiencing the devastating problems firsthand. They were in a sense documenting a historical moment. It addresses the gaps in mainstream media. The idea behind this form of journalism is that people without professional training are able to use modern technology tools and the internet to fact check, augment, or create media. This entails that anyone who has access to the web can start a blog or can report some events across the digital world. This is significant in a way that it addresses the gaps within mainstream media. It empowers local communities. Citizen journalism enables individuals who are previously excluded from essential information to increasingly participate in disseminating information to advance their well-being. This journalistic innovation is said to help improve local economies, sharing substantial information to remote corners of the globe. With it, many ordinary people are now able to play a part in telling stories, including their own, that are usually understated by mainstream media. although citizen journalism has received positive reviews from both citizens and media professionals, there are several issues that are currently being addressed. The negative impacts are: it poses difficulties to the audience about what to believe. One big problem with this type of journalism is that it will be difficult for people to decide what to believe, unlike traditional journalism, where it is safe to assume the information disseminated is factual. This means that citizen media should be checked and rechecked for accuracy to produce news that is suitable to print. As you can see, anyone these days can record and write anything and then present it as fact. So it is important to remember that we are dealing with humans here, and it is our nature to edit information to our own likeness, which can make unofficial news unreliable. It has limited audience in some cases. By publishing their work on social media, citizen journalists will have limited audience, such as only to their friends. And while blogging will make their audience a bit greater, it would never be as widespread as international broadcast on radio or television. Basically, citizen journalism just do not have an audience that is large enough to make a real change across the world. Bias in reporting the news. While professionals were trained to look at both sides in a particular story before they make any report, citizen journalists are considered biased at some point. Aside from the lack of training, they aren't always capable of providing credible information to public. Copyright issues can be overlooked. There is a tendency for citizen journalists to overlook some necessary copyright laws. For instance, they may fail to keep the identity of some materials without the consent of copyright owners. Ethical aspects. With respect to ethical problems associated with the dissemination of misinformation, it should be noted that most citizen journalists, who are typically not trained in reporting, are unaware of ethical codes within journalism, such as a need for fact-checking and source confirmation. A second ethical concern relating to privacy pertains to the possibility that dissemination of information, including photos about individuals without their consent, may compromise their dignity. Both forms of journalism are essential today. Citizen journalism and social information networks will flower in a marriage with enhanced professional journalism, not as a replacement for it. The relationship between traditional media and citizen journalism is changing daily. Simultaneously, both models learn from each other and improve themselves. Now, let's discuss some of the famous citizen journalism websites. The first one, All Voices. All Voices is a US-based citizen media website that has been on the go for over 3 years now. It's pretty high traffic, and the user-generated news website is a very good platform for citizen hacks from across the world to share what's happening where they are. And the second one, Oh My News, is a South Korean online news website with the motto, "Every citizen is a reporter." It was founded by Oh Yeon-ho on February 22, 2000. It is the first news website in Korea to accept, edit and publish articles from its readers in an open source style of news reporting. About 20% of the site's content is written by the 55% staff, while most of the articles are written by other freelance contributors who are mostly ordinary citizens. Many anti-South Korean government articles are written by journalists and time to time supports the ideology of the DPRK. The third one, CNN iReport. It's a community that enables news reporting from different angles and lets users share and discuss stories. Although it's a CNN platform, the stories aren't edited, fact-checked or even screened prior to being published. The beauty of iReport is citizen journalists have a genuine platform for making it into the mainstream media, as CNN producers do monitor the content, and if something is unique or compelling enough, it can make it onto CNN. These stories are marked CNN iReport. The fourth one, Now Public. Now Public has 5 million monthly readers, and its content covers everything from technology and environment to health and sports. Articles are written based on the trending issues of the day by contributors who add in background information, photos and videos. Contributions come in from citizen hacks in over 160 countries. It's a pretty straightforward tool to use, but new users' first posts are monitored for quality and to ensure it's not spam. All subsequent posts should go live as soon as you publish, and the people behind it will advise if there are any issues with the content. And the fifth one is Wiki News. Wiki News is an offshoot of Wikipedia, and as with the online encyclopedia, Wiki News is a free content collaborative platform. Co-founder Jimmy Wales has previously distinguished Wiki News from Wikipedia by saying, "On Wiki News, each story is to be written as a news story as opposed to an encyclopedia article." As with Wikipedia, Wiki News is all about the neutral point of view policy, which is in contrast to other citizen journalist websites which include opinion-led editorial. If you have ever contributed to Wikipedia, the Wiki News interface will be familiar to you, and it works in pretty much the same way. The sixth one is MerryNews.com. MerryNews.com is a citizen journalism based news platform for citizen journalists in India and across the globe. This is an English language web portal in India built on the concept of citizen journalism. The website is owned by Bizol Advisors Private Limited and allows anyone to share news, opinion, analysis, reviews, photos and events. Merry News also has city-based local print editions in metropolitan areas in India. Conclusion: the concept of citizen journalism did not have much effect on the media or the citizens a few years ago, but the advancement in technology and citizens having a tool like internet and mobile phones applications, they began actively participating in events and reporting news and sharing them on common platform. Looking at the potential and speed at which news and information were shared, media started to use their contents, videos and photographs. As a result, more and more came forward and began to act as citizen journalists. Now, with the growing trend of citizen journalism, citizens are making a serious effort to bring in whatever they think is important in the forefront, which has been neglected by the media. Let me summarize what we have discussed so far. Today, be it the print media or television or new media, there are opportunities for ordinary citizens to report issues around them and actively participate in public discourses. This new kind of journalism is a significant initiative on the way to the democratization of the media. One of the greatest advantages that citizen journalists have over mainstream media is speed, by which the news and images can be shown in television or over the internet. Thus, the popularity of citizen journalism no longer in question. Even the national media around the world are sourcing leads from stories and pictures filed by citizen journalists. This chapter discusses the process of citizen journalism in detail, the major differences between the traditional and citizen journalism, and what all impacts that citizen journalism is raising in this world. Now, you can try to answer the questions given here. 1. How would you describe the relationship between a citizen journalist and a professional journalist? 2. What is citizen journalism? 3. What else is citizen journalism called? 4. How does citizen journalism mesh with traditional media? Hope that you may go through the reference books for further reading. Citizen Journalism Global Perspectives, written by S. Allen and E. Thorson, published by Peter Lang Publishing, 2009, New York. Preparing for an Age of Participatory News, Journalism Practice, Volume 1, Number 3, written by Emmrc, Emmrc, C. Newberger in 2007. Citizen Journalism versus Traditional Journalism, page number 16 to 27, written by Barnes C., published by Caribbean Quarterly in 2012. Thank you for watching this program. We can meet again with another topic. Have a nice day.
Welcome to the Interface program. Today we have Professor Ramaprakash from Inter-University Center for Astronomy and Astrophysics, Pune, as our guest. He has been involved in many astronomical instrumentation projects involving many countries. A warm welcome to Professor Ramaprakash.
Thank you, Ravi. It's a great pleasure to be here with you today, and I look forward to having a good chat with you.
So, as I know that, I mean, you are coming from an engineering background. So, how do you develop basically astronomy and astrophysics, and your interest in astronomy and astrophysics, or how did you end up in astronomy?
Yes, it's a interesting question. To be honest, I think it was also all a coincidence. Once I did my electronics engineering from College of Engineering, Trivandrum, in 1992, and the only decision I had made at that point was that I am not going to be an executive in a company or working for an industrial job. I wanted to continue in academics, but I was not clear at that point what area I would like to work on. I was exploring various options, and it so happened that I ended up in astronomy. And astronomy is always a fascinating field, and anybody who has any interest in science, technology, will immediately get attracted to astronomy. The moment you go by anywhere near it, the attraction of astronomy pulls you in, and I fell into it and I fell in love with it, and now I am an astronomer.
And second thing, actually, the area you are working is astronomical instrumentation. That also is not too popular, or I mean, I should say it was a courageous decision to get into it. Can you elaborate the activities that you are doing at IUCAA?
Yes, so let me give a little bit of background to that. In IUCAA or any other astronomy institutes in the country, usually people come from MSc background, mathematics background, and science background in general. But it is not unusual to have people coming from other backgrounds like me. With electronics engineering, there are mechanical engineers, software engineers working in astronomy. So astronomy is a field which requires talent from every possible pool, especially in today's world where the instruments used for astronomy, like the telescopes, the spectroscopes, they are very complex, extremely technically challenging instruments to build. So it requires people from all fields. Now, if you're going back to my specific case, when I started working for a PhD in astronomy at IUCAA, I had to also take an MSc, because that was a requirement that if you do not have a master's in physics or science, you cannot get registered for a PhD in astronomy. So this forced me to take a master's in physics, MSc in physics, as well as then move on to a PhD in astronomy. The advantage it gave me is tremendous. It was very difficult at that time when I did that, but the advantage it gave me was tremendous, because if you have a specific problem to solve, the way a scientist would look at that problem is very different from the way an engineer would look at that. A scientist would like to have a theoretical understanding of the problem, the general class of problems, the solutions to general class of problems, and then have a top to bottom approach. On the other hand, an engineer is most concerned with solving that problem without really worrying about what is the global picture, what leads to that kind of situations in general, and so on. I want to solve this problem, I want to make progress, I want to deliver my product in time. So it's a different approach. So the same problem is viewed by these two groups of people differently. And I must say I am able to sort of bridge the gap between these two groups. When an engineer speaks about a problem and a scientist speaks about a problem, they might be speaking about the same thing but different languages in practice. and someone to bridge that gap and translate a scientific requirement to an engineering problem and then solve it, and then get the data required for the scientists to understand the situation. That's I think where my role in general fits into the overall scenario of things, and I think that's a niche area, and so I'm glad that I did that at that time. I was forced to do that, and I did that, and it is helping me a lot in general.
Okay.
So coming back to your specific question about what kind of activities we do in the instrumentation laboratory at IUCAA. IUCAA's lab started out as a small facility. Even now it is a small group by laboratory standards, like a CSIR lab or a big facility in particle physics. It is a very small lab, about 20 people work there. But we identify very niche areas and then try to use technology which is becoming available now to push those niche areas and find applications for that in astronomy, so that you can do unique things.
And that's in a global fashion.
In a way that it is attractive internationally or globally. So we try to specialize on those kind of things rather than trying to do many things at the same time and make slow progress. We try to identify. Three specific examples I can mention are any astronomy system requires sensors, because astronomy is all about sensing light or other radiation coming from distant sources. So you use telescopes to collect the light. The telescope is only a light collecting bucket, and it brings the light to its focus. At the focus you need various kinds of optics and sensors which can translate that light into information which an astronomer needs. And these sensors are very expensive and exquisite components of an instrumentation system. So we specialize in developing controllers for these sensors to acquire data from the sensor, the electronics, the software for these sensors, which are not many groups around the world are experts in doing that. And we specialize in that, and our controllers, our sensor controllers are used in almost all big facilities around the world, big observatory facilities around the world. Similarly, we develop technologies using optical fibers for applications in astronomy, very unique applications for spectroscopy. What is called hyperspectroscopy or two-dimensional spectroscopy and so on, area spectroscopy. We use adaptive optics to improve the quality of data which you can get from astronomical telescopes. So there are these very specific niche areas where we develop technology in the lab and apply it to astronomy to get a unique instrument.
Yeah, since you were talking about adaptive optics, will you be able to explain it a little bit more, because not everybody will be using or understanding it?
Okay, I will try to. It is a very complicated optical system, but I will try to explain it as a few words as possible. We all probably have come across adaptive optic systems in our lives, almost all of us. For example, if you are someone who wears spectacles and you go to a shop to get your eye tested, the doctor there usually nowadays have an automated machine. He will ask you to look through the machine, and in the machine you will see some things going back and forward and then coming to focus and adjusting. So that equipment is measuring the eye's response to certain signals coming in and reacting to it and adjusting, and then in that process trying to measure the performance of your eye, and then trying to figure out what compensation you need using spectacles. So this is adaptive optics, and that optics is reacting to a system and try to adjust for it and compensate for it so that you can measure it. In astronomy, what happens is when light comes from this very faraway objects like stars, galaxies, etc., most of the time light is passing through space, and space is basically empty. So the light just passes through the space, and that's how it arrives on Earth. But once it comes above that Earth, there is atmosphere, and the atmosphere has a lot of particles, oxygen, dust, other particles in the atmosphere, nitrogen. And as light passes through the atmosphere, the light is affected because the atmosphere is not very stable. It's a turbulent medium. It is changing very fast. All the time the atmosphere is changing because human activity going on, winds are blowing, or the sun is heating the atmosphere, Earth is rotating, all kinds of activities. So the atmosphere is not a stable medium. The light has to pass through this medium, and because of the turbulence in the medium, the image of the object you are trying to look through a telescope gets blurred. It becomes sort of, I wouldn't call defocused, but blurred. Now, this is a serious limitation to do in astronomy, because then you cannot see very fine details of objects you are looking at because the light is blurred by the atmosphere. So, adaptive optics uses lasers to measure the instantaneous effect an atmosphere has in the light as it passes through from your target, and then use some optics to compensate for it, so that the effect of atmosphere is nullified by as much as possible in real time. So it's a continuous process in real time, and that is of tremendous application in astronomy, because all major telescopes, observatory facilities will have adaptive optics to compensate for it, for the atmosphere. The only other option is to go to space above the atmosphere, which is very expensive, and an observatory on a ground-based observatory, you can maintain it for hundreds of years, maybe 100 years. You can, as technology improves, you can go and easily upgrade it, put new instruments there. But space-based telescopes have a limited lifetime, 5 years lifetime, 10 years lifetime. They are very expensive, and if you have to repair anything, it's not easy to send someone up there to repair or upgrade and so on. Yeah. So these are complementary. So if you have to completely nullify the effect of atmosphere, you go to space. That is expensive and can do very specific things. But if you want a general purpose, long-standing observatory, you build one on ground and then maintain it for a long time. And also, if you want a 30-meter diameter telescope, which is very, very large, you cannot launch it into space. It's impossible. No, modern technology cannot do that. So they have to be on ground. So there are merits and demerits for both approaches. So there are many ground-based telescopes, and there are space-based observatories also.
Yeah. Coming back to the instrumentation scenario, how tough is the, or how in general, what is the basic requirement that you are asking from a student to get into astronomical instrumentation, say?
Okay. This is very interesting. In general, if you want to come to astronomy, what one is looking for is good understanding of physics, mathematics, and related subjects, which you study as part of a science curriculum. That's what is usually required to work in astronomy. If you want to involve in building instruments for astronomy, you can always you can be coming from an engineering background, or even if you come with a physics background and you are good at experimental setups, making equipment, playing around with hardware and software and things like that, you can always pick up those skills. So I think a basic skill at a master's level in physics, mathematics, and an ability to, or an interest in making things and even breaking things while trying to make them, and that is what is essentially required. An engineering background is not essential. But as I said earlier, if you have a basic training of engineering, the way you would look at problems could be different, and then you could play that role, but that's not essential. There are mechanical engineers who are doing very high-end theory in astronomy. There are engineers who are doing numerical simulations in astronomy. There are scientists who come from physics background who are building instruments in astronomy. So it is a need-based and an interest-based science. But you have to be good at what you are trying to do, and you must have a drive to do this, solve difficult problems, and push things to their limits, and don't give up easily. That's basically what you need. And once you have that attitude, I think you can do what is required for astronomy. Then it's not the background is not so
the drive is
important. You have to be good at what you basic science or engineering is, but then you can pick up what is required.
Okay.
That's my expression.
Okay, that's actually a good thing, because if you have the drive, then you can definitely come up.
Exactly. So that's what I feel. Okay. The background is important, but it's not a dominating factor. The drive is a dominating factor. I want to do it. That's what should be there.
So coming, what are the major opportunities arising nowadays for a student to look forward in astronomical instrumentation, say, or in astronomy in general?
Yes, I think we are in the golden age in astronomy at this point of time. So all those people out there who are doing their bachelor's or master's, this is the right time to get interested in astronomy and see if you can contribute to it, because around the world there are many massive new facilities coming up in astronomy. Like the 30-meter telescope is an example where India is participating. There is the square kilometer array, which is a radio telescope. Again, India is participating. And recently, many of you would have heard about the gravitational waves and the first detection of gravitational waves. And one of the next advanced gravitational wave observatory is planned to be set up in India. And if you look at many of these programs, India is making an active participation in many of them. So it's a golden time for students to understand what these projects are and develop interest in them and contribute to that. And it is a wonderful time to be in astronomy. So I'm sure there are many opportunities for physicists and scientists and engineers to contribute to various facets of this facility building which are coming up. They could be ground-based, space-based, all kinds of wavelengths from gamma rays to radio waves. The facilities coming up all over. So the next decade is going to be a decade of discoveries. These facilities will become operating after about 5-10 years of time. They are complex facilities, so they require 8 to 10 years to build. And once they become operational, they will ask some of the most fundamental questions you can ask. For example, questions like, is there life anywhere else other than Earth? Can we see evidence of life anywhere else in Earth, in the world? What is the overall structure of our universe in which we live in? How do these galaxies and stars which we see, how them form, and what kind of structure do they look at in the large scale? How do black holes form, supermassive black holes form, and how do they evolve? All kinds of fundamental questions which you can ask will be addressed by these facilities. So it's a golden time.
Right.
If you look at the way astronomy has progressed, there were millennia when after people started looking at the sky with the naked eyes and recorded movements of objects in the sky and try to understand patterns of movements and so on. Millennia passed, and only about 400 years ago someone had the thinking to use and point a telescope to the sky Galileo, and it opened up a new world. It opened up unimaginably new things for us to understand. For example, it told us that instead of the earth being at the center of the universe, it is the sun around which the earth is going around, and the planets are going around. Sun itself is not a blemishless star, it has sunspots, and all kinds of new things. Similarly, when these small telescopes were being used and in operation, that happened for several hundred years, and technology improved. And when 1 meter size aperture telescopes started being made, it was the 1 meter class telescopes which told us, the observations using 1 meter class telescopes which told us that our universe is expanding. So this is unthinkable at that time. How can the space itself expand? There was concepts or a theory behind it, but it is not clear whether it's an expanding universe, it's a steady universe, what happens after a long time, or what happened a long time in the past. So the idea of an expansion of the universe came with 1 meter class telescope. Similarly, every time a technology leap happens and new facilities come up, new windows into the universe open up, unimagined new discoveries are made. That's what is challenging, that's what is interesting, and that's going to happen in the next 10 years. Many new discoveries. So it's the right time to be in astronomy.
Well, how does our research, especially the standards of astronomical instrumentation, stand with regard to this that is available in the country, in the world?
Okay, so there are 3 answers to that question. So let me tackle that one by one. If you ask me how theory is going on in astronomy, theoretical developments in astronomy, I think we are doing very well. So theory requires, we have a tradition of
doing
theoretical things and doing theoretical developments. Chandrasekhar, Saha, any number of names, even in the new, we need not go to Aryabhata's time. Even in modern times, there are many stalwarts coming from India who have done path-breaking theoretical development. So in theory, we are doing pretty well in the international scene. As far as observations are concerned, observational astronomy require facilities like large telescopes, very complicated instruments to carry out those observations and analysis of data and so on. That is not exactly at the same level as theoretical stage, basically because in India we do not have large facilities comparable to everywhere else in the world. As an example, when India built a 2.3 meter Venu Bapu telescope a few decades ago, the largest telescope in the world had an aperture of 4 meters. So we are competitive. So 2 meters, then we can always think of making the next level of progress, and we could do. We are only one step behind. Fast forward several decades to today, the largest telescope in India today is a 3.6 meter telescope, and that was commissioned only a few months ago. To go from 2.3 meter telescope to a 3.6 meter telescope in our country, it took decades. In the meantime, the world has progressed from 4 meter class telescopes to 8 meter class telescope to 10 meter class telescope. Now they are building 25, 30 meter class telescopes and even thinking about 100 meter class telescopes. So the facility gap is huge, and that is limiting our observers from competing at an international level. Individual observers who have collaborations and have individual access to these facilities manage to get the data they need to do their observational astronomy, but it's not done on a systematic way. I think that it is high time that we change that approach. We put in place a systematic process by which institutes and astronomers in this country can have access to the best facilities in the world, and only then can we compete meaningfully on a global scale. So that is required. Now on a longer time scale, the difficulty is that not many people are interested in building facilities. To build facilities, we need to learn how to build instruments. Instruments, a collection of instruments become a facility. To build instruments, we need to develop technologies. Now, a lot of effort is spent in India to develop technologies. We have the nano mission, biotechnology, you name any new technology, we have a mission to excel in that. But very often these technological developments which happen in our labs are not translated into applications which are usable in different fields. That gap is not getting
clear,
bridged very easily. So we do develop technologies, we do develop the theory for those technologies, but we don't convert those technologies into applications in real situations. And that is something which we need to address. In astronomy specifically, we find it very difficult to attract students who want to build facilities and make instruments and build facilities. And that is something which we need to address very rapidly, because we cannot go on observing time on facilities which somebody else has built. We need our own observing time.
Yeah.
We need to build our own facilities so that our own astronomers can use the telescopes and the facilities the way we would like to use it. So that requires building our own facilities. And for that we need to have a set of people who are willing to spend their time to convert the technologies into new applications and instruments, and then those applications and instruments to facilities. That is a long-term requirement, and that also we need to start now. So both aspects, in the intermediate time scale, we need to get immediately time in existing large facilities for the current crop of astronomers to push their science forward. And in the long run, we should invest heavily in building facilities in the country or at the best places in the world, but the facilities have to be conceived and developed by people in the country, or at least led by groups in the country in collaboration on an international scene. That, unless that is done, it would be very difficult to sustain a competitive scale of activity in the country. The theory may continue. Theoreticians get data from others' observations, and they can continue to develop their theory, but they also need to be inspired by observations done by my friend here or a colleague there who made a new discovery, and I need to be challenged to find a theory to explain that new discovery rather than finding a theory to explain somebody else's discovery somewhere else. And so that has to go hand in hand, the instrument building, facility building, using those facilities to make new discoveries, new ideas, and then the theory to explain that they have to progress together. But we have a 3-level thing. Theory is doing well, observations not so well, facility building nowhere in the international scene. That's a difficult situation.
Yeah. So it was very wonderful to talk to you, Ram Prakash. Thank you for coming to the Interface program.
Thank you very much. Yeah. It was a pleasure.
Welcome back to yet another session. In this session, we will discuss epistemological method of rationalism and empiricism. The dawn of modern philosophy characterized chiefly by the reflection of scientific spirit, gave much prominence to epistemology or theory of knowledge. The continental rationalism and empiricism are the two outstanding epistemological methods that sought to give justification to knowledge practices along with its source, origin as well as limits. These thought trends laid the foundation of all subsequent methods of knowledge. Rationalism holds that reason is the sole or primary source of knowledge. It asserts the power of human reason to reach sure and universal knowledge. Rational mind can attain knowledge with the help of self-evident concepts and principles. Rationalists often believe in a theory of innate ideas, according to which these truths are innate to the mind, that is, they are part of the original dispositions of the intellect. Rationalism insists that no certainty can be attained by the means of our senses. It is also not possible to attain certainty about the objects of sense experience. What can be known are mental objects, and these are known not by senses but through reason. Rationalists often assert that the objects that can be known with complete certainty are the real and the prominent ones of the world, and that the others are either illusionary, unreal or trivial. Empiricism commences with the actual situation of human life and to examine what information we have, where we get it from, and what degree of reliability it may have. Empiricists find it futile to search for absolute truths about the so-called real world. They insist that we should start by examining sense information, even though it may not be completely certain. The sense data is the source and the foundation of human knowledge. Empiricists seek to relate the contents of our mind, our knowledge and beliefs, and their acquisition to sense-based experience and observation. Experience is the touchstone of truth and meaning, and that we cannot know of things which go beyond our experience. Rationalists hold that pure reason can be a source of knowledge and ideas. Rationalists' view is that isolated pieces of factual belief are insignificant compared with the certainties of a rational system of knowledge, such as geometry gives us. As for our initial ideas, some of them are innately built into the mind and do not come from experience. The limits of knowledge and of intelligibility are not set by experience. Empiricists claim that we can know reliably only what comes to us by sensory experience and by observation and experiment and by testing through experience. Knowledge is based upon the senses, upon the flux of the sensible world. Empiricism gives primacy to sense experience over reason. They reject the theory of innate ideas and refuse the claim of rationalism that reason alone is capable of providing genuine knowledge. The epistemological method of both trends, rationalism and empiricism, can be known through their representative thinkers. The prominent rationalist philosophers are Descartes, Spinoza and Leibniz. Empiricism is best reflected in the thought of John Locke, George Berkeley and David Hume. The rationalist doctrine that complete understanding of a proposition is sufficient enough for a person to know whether the proposition is true or false has been forwarded in Descartes' work Rule for the Direction of the Mind. A man who understands a proposition perfectly is one who can reason correctly with it, can see all that it entails and all that it denies. Influenced by the certainty of mathematical method, Descartes wanted to form such an accurate philosophical method. In his book, Discourse on Method, he outlined 4 rules to be followed in the method of philosophical investigation, which are as follows. First one, accept nothing as true which you do not clearly and distinctly know it to be so. Second one, divide each problem into as many simple parts as possible and arrange these parts in order from the simplest to the complex. third one, carry on the reflections in due order, starting with solving the simplest and rise little by little or by degrees to knowledge of the more complex. And the final one, make enumerations so as to make sure that no omissions have been made and no mistakes has been committed. Descartes held that nothing perceived by the senses is clear and distinct. So he suggested intuition as a source of clear and distinct ideas. A series of intuitions constitute a demonstration. By reviewing the demonstrations carefully, one becomes absolutely certain of conclusions drawn. If we limit our assertions to the clear and distinct ideas which are known intuitively, error is impossible. If we are impelled by emotions or prejudices or confused ideas, we make assertions for which we have no clear idea and distinct knowledge, and we commit error. In developing the epistemological method, Descartes also developed a skeptical approach, which later came to be known as initial skepticism. This method starts with doubt. Everything is doubted. He doubted his own sensations, memory, waking thoughts, existence of external world, the truths of mathematics, and even his own existence. Then he found that there is one thing which he cannot doubt. That is, he cannot doubt the fact that he is doubting or thinking. That means he cannot doubt about his doubt. Since the doubt exists, there must be a doubter. This led to the conclusion, cogito ergo sum, which means I think, therefore I exist. Thus, Descartes proved his existence. Based on this epistemological method, he forwards to establish his metaphysical speculations like existence of God, mind, and matter as substances, along with his insistence on dualist metaphysics and his attempted explanation of mind-body relation through the theory of interactionism. Spinoza follows Cartesian method, but seeks more consistency and systemization. The metaphysical idea of substance is worked out in a logically consistent manner and brought about monism in the place of dualism. It gave way to pantheism and psychophysical parallelism. Spinoza adopts a geometrical method. Everything follows from the first principle as necessarily as the propositions of geometry follow from their logical presuppositions. The universe is conceived as a causal chain in which each link is necessarily connected with the preceding link, just as in a process of reasoning, every conclusion is grounded on premises. Spinoza tries to solve the problem of deriving the many from the one by his doctrine of modes. He defines mode as the modification of substance which exists in and is conceived through something other than itself. He speaks of finite modes and infinite modes. According to him, God, the substance, in the attribute of extension has the infinite mode of motion and rest. In the attribute of thought, God possesses infinite mode of intellect. Through these infinite modes, one universal substance takes the form of various objects of our daily life. The human beings, plants, animals, sticks, stones, and every particular thing in the world are finite modes. Leibniz carried forward the rationalist claims through his theory of monads. They are centers of force, differing quantitatively. They are mental, absolutely simple substances, not composed of extended parts and cannot be decomposed. Therefore, monads are indestructible and immortal. All monads are graded in accordance with the degree of perfection they have in mirroring the universe. The bare monads, the lowest ones, constitute the inorganic world. Monad at the top is the supreme monad, and this is God. In man, monad is a reasonable spirit. These spirits reflect, they are aware of their own selves. They are also capable of using the logical principles of contradiction and sufficient reason. God has created a pre-established harmony between the monads, rendering every monad in agreement with all the other monads at all time. The world we experience forms only a very small portion of the whole universe, and we know the world only for a very short period of time.
empiricism. The term empiricism is derived from the Greek word empiria, which means acquainted with. The Latin translation is experientia, which means experience. Empiricism takes experience as the touchstone of truth and meaning. It assumes a stratified form in which the lowest level is issued directly from experience and the higher one is based on the lower level. John Locke, in his book Essay Concerning Human Understanding, surveys the territory of human knowledge. He states that all materials of human knowledge are derived from experience, either of the external world through our sense or our mental life through introspection. Rejecting the Cartesian notion of innate ideas, Locke holds that the mind of human being at the time of birth is like a blank tablet, an unwritten paper devoid of any ideas. All ideas are acquired from experience. Innate ideas hinders the path of free inquiry. True knowledge is to be found by the active employment of human faculties. That is why Locke used the metaphor of tabula rasa or blank slate or empty chamber to refer to the mind of an infant. Epistemology occupies the center position in Lockean philosophy. He examines the nature, origin, validity, and the limits of knowledge. Philosophy is looked upon as the true knowledge of things, including the nature of things, that which man ought to do as a rational voluntary agent, and the ways and the means of attaining and communicating such knowledge. Locke explained the origin of knowledge in terms sensation, reflection, and experience. All objects of our mind are ideas derived from sensation and reflection. Through sensation, the mind is furnished with sensible qualities. Many ideas are formed when our sense organs are affected by external objects. Some other ideas are received by reflection, when we perceive the operations of our mind on the ideas. All our ideas are either simple or complex. Simple ideas are atoms out of which all knowledge is composed. The mind, by its innate power of compounding, comparing, and abstracting, put together simple ideas and make new complex ideas. Simple ideas enter our mind in 4 different ways. Some simple idea enters our mind by one sense only, some by more than one sense, some by reflection, and some other through both sensation and reflection. According to Locke, ideas should be clear, distinct, so as to become knowledge. The most certain knowledge is the perception of agreement or disagreement between our ideas. When this agreement or disagreement of ideas are perceived by direct inspection, it is intuitive knowledge. If it is established indirectly by comparing them with one or more ideas, it is called mediate or rational or demonstrative knowledge. Our knowledge of the particular existence of finite external things goes beyond bare possibility, and this is called sensitive knowledge. George Berkeley upheld empiricism and insisted that all our thoughts exist in the mind. They cannot exist outside mind. The existence of anything consists in being perceived by a mind. The same thing is true of our sensation. For him, existence is identical with perception or esse est percipi. This is termed as subjective idealism. The cause of our sense experience must be an active substance. It cannot be matter because unperceived matter is an abstraction which cannot be believed. Berkeley was convinced of the capacity of human mind to cope with the problem of knowledge. The desire for knowledge can be satisfied by a proper use of our faculties. However, mind is incapable of framing abstract ideas. A general idea is one which, considered in itself, is particular, but which becomes general by being made to represent or stand for all other particular ideas of the same sort. The objects of human knowledge are either actually imprinted on the senses or are perceived by attending to the passions and operations of the mind, or ideas formed with the help of memory and imagination. These ideas are compounded, divided, or merely represented. Besides ideas, there is something which knows or perceives them and exercises diverse operations as willing, imagining and remembering them. This perceiving, acting being in mind, spirit, soul, myself, says Berkeley. David Hume, another representative of British empiricism, asserts that knowledge has its source in experience. For him, our knowledge is limited to the world of phenomena. He held that all the materials of our thinking are derived from inward and outward impressions. Lively perceptions are called impressions. When all sensations, passions, and emotions make their first appearance in the soul, impressions are made. All our thoughts or ideas are copies of such impressions. They are less lively perceptions. They arise when we recall impressions on sensation. Impressions are either outward or inward. Outward impressions arise in the soul from unknown causes. Inward impressions are created by our ideas. For instance, we have an impression of heat, of which an idea or a copy remains. The ideas produce new impressions like fear. These again are copied by the memory and imagination. From such impressions, all our knowledge is derived. Knowledge results from compounding, transposing, or diminishing the materials furnished by the senses and experience. Our ideas or thought are not unconnected. They are related together with a definite method and regularity. Different ideas are connected together by the law of association of idea. These are the laws of resemblance, contiguity in time and place, cause and effect. Hume divides human knowledge into relations of ideas and matters of fact. Of the first kind are the truths of geometry and algebra, and also every affirmation which is either intuitively or demonstratively certain. For example, 3 times 5 is equal to half of 30 expressions a relation between these numbers. Propositions of this kind are discoverable by the mere operation of thought. Matters of fact are not ascertained in the same manner. The contrary of every matter of fact is possible. All scientific knowledge and principles such as cause-effect relationship belongs to matters of fact. The knowledge of cause and effect is derived from experience and custom. There is no absolute self-evident knowledge of matters of fact. Our knowledge never reaches absolute certainty. By basing our conclusion on experience, we believe that the future will be like past, but we have no absolute assurance. Epistemological discussions becomes fruitful only when a proper method is employed. In Western philosophy, the modern times saw the emergence of rationalism and empiricism as the two opposing epistemological methods which imbibe scientific spirit. The session shows how various thinkers within the same tradition differs from one another, thereby leading to different approaches within. The initial skepticism of Descartes, monism and pantheism of Spinoza, and monads of Leibniz expounds rationalist method. The empiricist method is expressed in Lockean rejection of innate ideas, Berkeley's subjective idealism and skepticism of David Hume. Before we move to the next session, please try to answer the following questions. First question, bring out the chief characteristics of rationalism and empiricism. Second one, examine the relevance of rationalist method in epistemological inquiry. Third question, analyze the role of John Locke in the development of empiricism. Fourth question, explain subjective idealism. Fifth question, elucidate the contributions of empiricism as an epistemological method. Here are some books for your reference. From Socrates to Sartre, The Philosophical Quest by T.Z. Lavin, published in 1984 by Bantam Books. A History of Philosophy by Frank Tilly, published by Allahabad Publishing House. A Critical History of Western Philosophy by Y. Mashi, published by Motilal Banarasi Das Publishers in 1996. Hope this session was useful for you. See you next time. Until then, bye.
Hi friends, in the previous session we have discussed about continuity and derivatives. Now we discuss about Cauchy-Riemann equations. That is, we are going to obtain a pair of equation that the first order partial derivatives of the component function u and v of the function fz is equal to uxy plus I Vxy. This must satisfy at a point z0 is equal to x0 y0 when the derivative of f exists there. We also show how to write f dash z0 in terms of those partial derivatives. So first we have Cauchy-Riemann condition theorem. First one, we have necessary part. Suppose fz is equal to uxy plus ivxy and that f dash z exists at a point z0 is equal to x0 plus iy0. Then the first order partial derivatives of the functions u and v must exist at x0 y0 and they must satisfy the Cauchy-Riemann equations ux is equal to vy and uy is equal to minus vx. Equation number 2. Also, f dash z0 can be written f dash z0 is equal to f dash z0 is equal to ux x0 y0 plus ivx x0 y0. That is equation number 3. The equations in 2 are called Cauchy-Riemann equations. So, named after the French mathematician A.L. Cauchy, who discovered them, and also in honor of the German mathematician G.F.B. Riemann, who used them in his theory of functions of a complex variable. Equation 3 provides a formula for finding f dash z0 in terms of the partial derivatives. Proof. Suppose that the derivative f dash z0 exists. We write z0 is equal to x0 plus I y0 and delta z is equal to delta x plus I delta y and of course delta w is equal to f of z0 plus delta z minus f of z0, which is equal to u x0 plus delta x y0 plus delta y . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . That is u x naught plus delta x, y naught plus delta y minus u x naught y naught plus I into, again we have v x naught plus delta x, v x naught plus delta x plus x naught plus delta x comma y naught plus delta y. Here we have y naught plus delta y minus v x naught y naught. Here we have the brackets. As the derivative f dash z naught is equal to, we can write f dash z naught is equal to as limit delta z tending to 0, delta z tending to 0, delta w by delta z exist. This exists. We then have f dash z naught is equal to limit delta x delta y tending to 0 0, real part of delta w by delta z, that is we can write f dash of z naught, which is equal to limit delta x delta y tending to 0 0, delta x delta y tending to 0 0, real part of delta w by delta z plus I limit delta x delta y tending to 0 0, imaginary part of delta w by delta z. Here we have imaginary part. This is equation, next equation number is 4. This is, here we have real part, here we have imaginary part. That is, we have a figure, here we have, this is our delta x and of course this is our delta y. Here we have 0 delta y, here we have delta x 0. Of course this is our origin 0 0. Now it is to be noted that expression 4 is valid as delta x delta y tending to 0 0 in any manner that we may choose. In particular, we let delta x delta y tending to 0 0 horizontally through the point delta x 0 as indicated in this figure. This means that delta y is equal to 0 and the quotient delta w by delta z becomes delta w by delta z is equal to u into x0 plus delta x y0 minus u x0 y0 by delta x. That is, delta w by delta z becomes, which is equal to u x naught plus delta x comma y naught, u x naught plus delta x, here we have plus delta x y naught minus u x naught y naught whole divided by delta x plus I into v of x naught plus delta x y naught minus v of x naught y naught whole divided by delta x. Thus, limit delta x delta y tending to 0 0, we have real part of delta w by delta z is equal to, that is, limit delta x delta y tending to 0 0. Here we have delta x and delta y which tend to 0 0. delta w by delta z becomes, sorry, it is real part of, that is limit delta x delta y tending to 0 0 real part of delta w delta z, which is equal to limit delta z delta x tending to 0, which is equal to limit only delta x tending to 0 u x naught plus delta x y naught u x naught plus delta x y naught minus u x naught y naught by delta x. Here we have delta x tending to 0, which is equal to u x x naught y naught, and again limit delta x delta y tending to 0 0, imaginary part of delta w by delta z becomes limit delta x delta y tending to 0. Next we have imaginary part of delta w by delta z. This becomes limit delta x tending to 0, limit delta x tending to 0. Here we have imaginary part, so we have v x naught plus delta x y naught minus v x naught y naught by delta x, which is equal to Vx of x naught y naught, where Ux of x naught y naught and Vx of x naught y naught denote the first order partial derivative with respect to x of the functions u and v respectively at x naught y naught. Substituting these values in equation number 4, we find that f dash z naught, we can write this f dash z naught is equal to ux x naught y naught plus ivx x naught y naught, equation number 5. Now we let delta z tend to the origin 0 0 vertically through the points 0 delta y. This means that delta x is equal to 0 and the quotient delta w by delta z becomes that we can write delta w by delta z becomes u x naught y naught plus delta y naught, delta y naught plus delta y minus u x naught y naught whole divided by what we have the I delta y plus next term we have plus I into v, next term we have I into v x naught comma y naught plus delta y minus v x naught y naught divided by I delta y. This I can write as which is equal to v x naught y naught plus delta y minus v x naught y naught minus I into u x naught y naught plus delta y minus u x naught y naught by delta y. Thus limit delta x delta y tending to 0 0, that is limit delta x delta y tending to 0 0 real part of delta w by delta z, which I can write which is equal to limit delta y tending to 0, first term I have v of x naught y naught plus delta y minus v of x naught y naught by delta y. This is equal to what? Vy of x naught y naught. And also limit delta x delta y tending to 0 0. What about imaginary delta w by delta z? That is limit delta x delta y tending to 0 0, imaginary part of delta w by delta z, which I can write as, which is equal to minus, here we have negative sign, limit delta y tending to 0, u x naught y naught plus delta y minus u x naught y naught by delta y, which is equal to, which I can write as, which is equal to minus u y of x naught y naught. Hence, it follows from the expression 4 that f dash of z naught is equal to, you can write f dash of z naught, which is equal to vy x naught y naught minus I into uy x naught y naught. Mark it as equation number 6. Here we have negative symbol. As LHS of 5 and 6 are the same, it follows by equating real and imaginary parts that ux x naught y naught is equal to vy x naught y naught that is ux x naught y naught, which is equal to vy x naught y naught and also uy x naught y naught is equal to minus vx x naught y naught. Mark it as equation number 7. Here completes the proof. Next example, it's verify the Cauchy-Riemann equation for the function fz is equal to z square, and using our formula number 3, we have to find its derivative. The question is fz is equal to z square. If n is a positive integer, we have d by dz of z raised to n is equal to n z raised to n minus 1, that we have already studied. Hence, in particular, the function f defined by fz is equal to z square is differentiable everywhere, and f dash z is equal to 2z. Hence, the theorem is applicable. To verify that the Cauchy-Riemann equations are satisfied everywhere, we note that fz is equal to z square can be written as, this can be written as x plus iy whole square, which is equal to x square minus y square plus I into 2xy. Here uxy is equal to x square minus y square this one is uxy and vxy is equal to 2xy. Thus uxy is equal to, we can write dou u by dou x, dou u by dou x is equal to 2x, and of course vx of xy, that is dou v by dou x, dou v by dou x is equal to 2y, and also uy of xy, that is dou u by dou y, this dou u by dou y, which is equal to minus 2y And again we have dou v by dou y, that is here dou v by dou y, that is equal to 2x. Hence we have ux is equal to vy, ux is equal to vy and uy is equal to minus vx. Hence Cauchy-Riemann equations are satisfied everywhere. Also by formula given by 3, at any point set we can write f dash set f dash is equal to ux xy plus ux xy plus I vx xy which is equal to 2x plus I 2y, taking 2 outside we can write 2 into x plus iy, or you can write this x plus iy, we know it is set, so it is 2 set. Next we have locating points at which f has no derivative. Since the Cauchy-Riemann equations are necessary conditions for the existence of the derivative of a function f at a point set naught, they can be often be used to locate points at which f does not have a derivative. So next we have an example to discuss the non-differentiability of the function f z is equal to mod z square at a z not equal to 0 using Cauchy-Riemann equations. That is f z is equal to mod z square. Taking z is equal to x plus iy. That is, so we have f z is equal to x plus iy, we have f z is equal to what? Mod z square. So it is mod x plus iy whole square. Or you can write this is equal to x square plus y square plus I0. We have uxy is equal to, here our uxy is equal to x square plus y square. So what about vxy? It is of course 0. So next we have to find ux, vx, uy and vy. So ux here is, that is ux means dou u by dou x, which is equal to 2x. Vx is equal to, of course, which is equal to 0. Uy is equal to 2y. And here we have vy is equal to 0. If the Cauchy-Riemann equations are to be held at a point xy, then we must have ux is equal to vy. We must have ux is equal to vy and uy is equal to minus vx. So that 2x is equal to 0 and 2y is equal to 0, which implies that x is equal to, here we have, which implies x is equal to 0, y is equal to 0. Hence the Cauchy-Riemann equations are satisfied only at the origin. Consequently, f dash z does not exist at any non-zero point. This theorem 1 does not ensure the existence of f dash 0 for the function in the previous example. To ensure this, we need sufficient theorem. Due to the importance of the examples, we will consider it again. Next is sufficient conditions for differentiability. Satisfaction of the Cauchy-Riemann equations at a point z not equal to x naught y naught is not sufficient to ensure the existence of the derivative of the function f z at that point. But with certain continuity conditions, we have the following useful theorem. That is Cauchy-Riemann condition sufficient part. Let the function f z is equal to uxy plus ivxy be defined throughout some epsilon neighborhood of a point z0 which is equal to x0 plus iy0, and suppose that first one, the first order partial derivatives of the functions u and v with respect to x and y exist everywhere in that neighborhood, and second one, those partial derivatives are continuous at x0 y0 and satisfy Cauchy-Riemann equations ux is equal to vy and uy is equal to minus vx at x0 y0. Then f dash z not exist, f dash z not exist, and its value is f dash z naught is equal to what we have ux x naught y naught plus I Vx x naught y naught. So we will move to the proof. We assume that conditions A and B in this hypothesis are satisfied and write delta z is equal to delta x plus I delta y, where 0 less than mod delta z less than epsilon, and also delta w is equal to f of, that we know, f of z naught plus delta z minus f of z naught. Thus we have delta w is equal to delta u plus I delta v. This we can mark it as equation number 11, next equation number 11, where delta u is equal to, this delta u is equal to u x naught plus delta x y naught plus delta y minus u x naught y naught. This is our delta u, and of course delta v is equal to v x naught plus delta x comma y naught plus delta y minus what, v x naught y naught. Now in view of the continuity of the first order partial derivatives of u and v at the point x naught y naught, delta u is equal to ux x naught y naught into delta x plus uy x naught y naught into delta y plus epsilon 1 into delta x plus epsilon 2 into delta y, that I can write. That is delta u into ux into x naught y naught into delta x plus uy into x naught y naught into delta y plus epsilon 1 into delta x plus epsilon 2 into delta y, equation number 12. And we have delta v is equal to, similarly we have delta v is equal to vx into x naught y naught into delta x plus vy into x naught y naught into delta y plus epsilon 3 into delta x plus epsilon 4 into delta y. Mark it as equation number, next equation number 13. where epsilon 1, epsilon 2, epsilon 3 and epsilon 4 tend to 0 as delta x delta y approaches to 0 0 in the delta set plane. Substituting expressions this 12 and 13 into our previous equation number 11, we obtain delta w is equal to ux x naught y naught delta x plus uy x naught y naught delta y plus epsilon 1 into delta x plus epsilon 2 into delta y. This is our delta u plus next term we have plus what I into next term we have vx x naught y naught into delta x plus vy x naught y naught into delta y plus epsilon 3 delta x plus epsilon 4 delta y. This I is common for this one. Mark it as equation number, next equation number we have 14. Assuming that the Cauchy-Riemann equations are established at x naught y naught, we can replace uy x naught y naught by minus vx x naught y naught and vy x naught y naught by ux x naught y naught, equation number 14, and we obtain, by replacing this we can obtain delta w is equal to ux x naught y naught into wx plus instead of uy we can write minus vx. This minus vx x naught y naught into delta y plus epsilon 1 delta x plus epsilon 2 delta y plus I into vx x naught y naught into delta x plus instead of vy I can replace it as ux. X naught y naught delta y, the same one, epsilon 3 delta x plus epsilon 4 delta y. Okay, that is I can write delta w is equal to ux x naught y naught ux x naught y naught delta x plus I delta y next one plus I into, I am combining this, plus I into vx into x naught vx of x naught y naught, the remaining term is x naught delta x plus I delta y plus the other terms plus what we have epsilon 1 plus I epsilon 2 delta x plus here we have epsilon 1 plus epsilon 3 here. For delta x we have epsilon 1 and epsilon 3 plus epsilon 2 plus I epsilon 4 delta y by combining this and this. That is epsilon 2 plus I epsilon 4 delta y. Now dividing throughout by delta set, that is delta x plus I delta y. The above gives delta w by delta z is equal to that is I am going to dividing throughout with a delta set. This equation becomes delta w by delta z. In the LHS we have divided by delta z, which is equal to ux x naught y naught plus I vx x naught y naught plus epsilon 1 plus I epsilon 3 epsilon 1 plus I epsilon 3 delta x by delta set plus what remains, the epsilon 2 plus I epsilon 4 into delta y by delta z. Mark it as equation number 15. Now noting that modulus of delta x less than or equal to modulus of, that is modulus of delta x less than or equal to modulus of delta z, and also modulus of delta y, here it is also less than or equal to modulus of delta z. We have mod delta x by delta z less than or equal to 1 and mod delta y by delta z less than or equal to 1. Hence, this modulus of, by using that modulus of epsilon 1 plus I epsilon 3 into delta x by delta z, which is less than or equal to, this is less than or equal to 1. So, I can write this is less than or equal to mod epsilon 1 plus I epsilon 3, which is again less than or equal to mod epsilon 1 plus mod epsilon 3. And similarly, we have this modulus of epsilon 2 plus I epsilon 4 into delta y by delta z. Again we have delta y by delta z is less than or equal to 1. This I can write as this is less than or equal to modulus of epsilon 2 plus I epsilon 4, which is again less than or equal to mod epsilon 2 less than or equal to, sorry, here we have plus mod epsilon 4. So, the last two terms of the right in equation number 15 tends to 0 as the variable delta z is equal to delta x plus I delta y tends to 0. This means that the limit of the left hand side of equation number 15, this limit exists, and that f dash z naught is equal to ux x naught y naught plus I vx x naught y naught. That is, we can write f dash z naught is equal to ux x naught y naught plus iv x naught y naught, ivx x naught y naught. Now this completes the proof. Next we have an example. We now examine the differentiability of the function f given by fz is equal to e raised to x cos y plus I sin y. That is, fz is equal to, here it is somewhat different, e raised to x into cos y plus I sin y. Where y is taken in radians and cos y and sin y are evaluated. Here u is equal to e raised to x cos y, v is equal to e raised to x sin y. This is our u, and v is equal to what? E raised to x sin y. Then dou u by dou x is equal to e raised to x into cos y itself. Dou u by dou x is equal to, differentiating we have, which is equal to e raised to x into cos y itself. Similarly, dou u by dou y, that is dou u by dou y, here it is e raised to x into cos y, so dou u by dou y, which is equal to minus e raised to x sin y, minus e raised to x sin y. Now dou v by dou x is equal to, no change, e raised to x sin y, and dou v by dou y is equal to e raised to x into cos y. Hence, here dou u by dou x is equal to dou v by dou y, and dou u by dou y is equal to minus dou v by dou x, and this verifies the Cauchy-Riemann equations. Also, the first order partial derivatives are everywhere continuous, and hence all the conditions in theorem are satisfied at all points in the complex plane. Thus, f dash z exists everywhere, and using equation number 16 we can write f dash z is equal to f dash z is equal to ux plus ivx. Which is again I can write which is equal to e raised to x into cos y. That is our ux is e raised to x into cos y plus I into e raised to x into, we have vy is equal to e raised to x into sin y, which is equal to, we can take e raised to x outside, that is e raised to x into cos y plus I sin y. In this example, we note that f dash z is equal to f z. Here we have f dash z is equal to what? F z itself. Next we examine the differentiability at the origin of the function f given by f z is equal to mod z square. Next example. We have seen in an earlier example that for the given function the Cauchy-Riemann equations are satisfied only at the origin. Also, the first order partial derivatives are continuous at the origin, and hence all the conditions in the theorem are satisfied at the point 0, 0. Hence, f dash z exists at z is equal to 0. Also, f dash 0 is equal to, we can write f dash 0 is equal to ux, that is at x at the point 0, 0 plus ivx at the point 0, 0, which is equal to what? 0 plus I0. For the function in the previous example, the Cauchy-Riemann equations are satisfied only at the origin, and hence derivative of the given function does not exist a point other than the origin. So here we discuss Cauchy-Riemann equations in detail, and we have done so many examples. Next we will discuss about Cauchy-Riemann equations in polar coordinates. Till then, take care.
Hello, welcome to in the course Ecology and Environmental Ethics. Gender has become an essential component of the emerging critique. Buddhism continues to be a living system of idea and ideas. A sacred grove is an ancient nature conservation tradition.
notes mentioned from 18 to more than 30 different schools of
This is the hinterland of Kasaragod, the northernmost district of Kerala. Hard laterite rocks and barren wasteland mark its topography. Grass and shrubs spring up only to dry out in summer, once again exposing the rocky strata. Puliyamkulam is a remote village in this barren land. This village has not felt the scarcity of water during the past 2 decades. A well located in the new scrub forest has been providing plenty of water even in acute summer. Thanks to this patch of forest that has grown silently around the village. About 3 decades ago, this was a barren land. The quality of its topsoil has been enriched today. What was once inhospitable terrain today plays host to a variety of trees and herbs. This is a forest that has been created in a wasteland. The creator of this green belt is Abdul Karim, a native of Nileshwaram town of Kasaragod. He was once a travel agent having offices in Dubai and many cities in India. He had cherished a dream of living a quiet life in tune with nature. To actualize this dream, he quit his job, purchased land, and went about regenerating a forest. He collected saplings of wild trees. Trusting his instincts, he planted them on the rocky terrain, braving the vagaries of nature.
പാരിസ്ഥിതികമായിട്ടുള്ള പ്രാധാന്യം അന്ന് അറിയില്ല. 72, 73, 74 ഘട്ടത്തിൽ പരിസ്ഥിതി നശീകരണം.
In the initial stages, I was not aware of the ecological importance of my effort. No one was aware of it in those days. But I had a dream, one of growing a forest, building a house and living in it. To start with, I purchased a small holding of 5 acres, paying rupees 3,750 in 1977. That plot had nothing on it except for some weeds. The well was dry. In the next rainy season, I started planting trees, mainly wide varieties of Maruda and Iruda. But the following summer was cruel. The saplings dried, but I persisted, often watering the plants in summer. As the plants began to grow, I became confident and continued my efforts. His endurance yielded results. The saplings began to grow. He was inspired and decided to expand the extent of his forest. Soon he purchased another 27 acres and planted saplings. For 3 consecutive summers, he nursed the plants and let nature do the rest. Amazingly, nature responded. The water table got enriched. The dry well inside the forest was now full of water. Karim was ecstatic. He dug up a new well and 2 ponds. To prevent soil erosion and to enrich the water table, he dug a long stretch of bund. In 1989, he built a house amidst the forest and started living there. He has never used fertilizers or insecticides, nor has he removed the weeds and log the trees. Now after 25 years, Karim's passion continues. His forest looks natural and he is familiar with every hedge and the life therein. Giant wood spiders which feed on the insects are in plenty here. The forest is also the abode of the Souther bird wing, the largest butterfly in South India. Nature lovers, scientists and researchers are welcome here. For them there is a varied, thriving forest life to study. Mosses, the primary species of any forest, exists in different kinds here. Lichens that grow in pollution-free zones have made their appearance in this forest. Various kinds of herbaceous plants with beautiful flowers can also be seen here. Canscora perfoliata and Cassia sesalpinioides are the most common flowering plants. Karim's forest is home to a variety of epiphytic orchids. Several sea climbers like Cisalpinia wind round the bushes and trees. Erythrina indica and Bombax malabarica are the most common spinous trees here. The other trees growing here are Strychnos nux vomica, Persea macarantha, Terminalia bellerica, Terminalia paniculata, Syzygium caryophyllum, Alstonia scolaris, and Xylea xylocarpa. The forest is abundant with many medicinal plants such as Narangamia alata, Holostemma adacodeon, and Aristolochia indica. Arundinella, a common herb of Kerala, has found hermitage in Karim's forest. The soil is becoming fertile and its water holding capacity is increasing. These are sure signs of the forest reaching its prime in the years ahead.
Once barren land, this area covering about 32 acres of land has now become a dense patch of moist deciduous forest. The major tree species are Terminalia, Xylea xylocarpa and Pterocarpus marsupium. Besides, a number of epiphytes, medicinal herbs and mosses are also established naturally in this area. The soil has now become very rich in humus. A number of seedlings of trees can be found here. A preliminary survey indicates the presence of over 300 species of flowering plants.
Karim's efforts have not gone unnoticed. The Environmental Monitoring Forum, a Cochin-based NGO, has honoured him with the P.V. Thambi Memorial Endowment Award for the year 2002. Such recognition has only strengthened Karim's passion for his forest. His is a quest for that oneness with nature that modern human life often aspires for. A quest worthy of emulation.
Welcome to the session on news portals. Digital technology impacted all domains of journalism. At first, it helped newspapers by revolutionizing printing technology and television and radio by digitally transmitting their content. After that, we witnessed the slow death of newspapers when their main service of news delivery is taken over by online journalism. Following it, radio and television were also fallen prey to digital radio and internet protocol television. This was not just a makeover from a style of presentation news to the other, rather it was a monumental shift in human culture and history. Newspaper was a major industry, a vital social service, a distinct culture, and more than everything, a nostalgic social habit. Now it is at the verge of extinction, at least in the West. And in the rest of the world, including India, warning bells started ringing. Same as the case of radio and television. Radio is fast retreating from public sphere, except for some city-centric FM stations. And television is desperately trying to catch up with the colossal strides of digital journalism. Digital journalism manifests its full strength and potential through large-scale news portals. They are magnificent and omnipotent, ready to deliver news wherever you are, in any form of your choice and any time you want. The coming years are of news portals and of digital journalists. In this session, we'll discuss what is a web portal, what is news portal, what are their characteristics, and the tips and tricks to successfully report and present news stories for news portals. Web portals. A website that serves as a main entry point to a specific field of interest or subject matter or industry is called web portal. It is a kind of cyber door to a sector. The specially designed elaborated website brings together information and data from various sources in a pre-designed uniform way. A portal offers some essential services. Let's list them first. A. Search engine facilities. B. Email facilities. C. Hyperlinks to external sites and sources. D. Personalized content section, which allows chatting, commenting, membership, downloads, etc. Facility to provide dedicated area called portlet for information display. F. Configuration facility for each user. G. facility for mashups and intranet dashboards for high-level or privileged users. I. Facility to display information depending on the intended user and intended purpose. American Online, AOL, MSN, NetCenter, Yahoo, etc. are global giants among portals. Normally, portals earn income through membership fees, advertisements and content selling. Here arises an interesting question. How do websites differ from portals? To answer this question, we have to find the elements of websites and portals, then to compare each of them. So first we can look at the characteristics of a website and then compare them with those of a portal, which we already listed above. A website is a collection of interlinked web pages typically hosted from a single domain. Website is accessible over the internet or a private network such as local area network (LAN) through an address known as Uniform Resource Locator (URL). The URLs organize the web pages into a hierarchical form which help a user to navigate through the pages. A home page is included that usually is a starting point of all navigation artifacts, including links to other pages, an About Us page or a Contact Us page. There are two types of website: static and dynamic websites. A static website is composed of web pages, the content of which remains constant until a developer wishes to alter. The information on a static website remains the same throughout. A static website may consist of plain text or rich media. However, on visiting a static site, you will see the same content at all times irrespective of the time of visit. On the other hand, a dynamic website updates itself frequently depending on a set of parameters. In other words, a dynamic website's content is renewed every time a user visits the website. While websites are considered as locations on the internet, publicly available with uniform resource locators or web addresses. For websites, no login is required and anyone can see the content. Content will not change for different individuals. Websites may have interactive features but do not reference personalized database. On the other hand, portals are private locations on the internet which are accessible with unique URL and with username and password. Unlike websites, portals require personal login and the content is visible only to the members. Content is unique to user based on linked account information and group member setting and permissions. In portal, each user has unique secure access points for personalized information which they can edit using passwords and usernames. Some portals provide facility for communication with other members of the portals. And the dynamic content on portals changes more often than a typical website. Major types of web portals. Personal web portals, example home.psaf. B. Government web portals, example kerala.gov.in. C. Corporate or industry or commercial web portals, example reliance.in. D. Cultural portals, example Digital NZ. E. News portals, example indiatimes.com. Of these, new portal is our topic of discussion. News portals. So far we discussed websites and portals and compared their characteristics. We have done it as a preface to our course subject, new portals. News portals are considered as the major tool to facilitate the web presence of news and views. That's the platform of online journalism or digital journalism. Now, almost all newspapers, radio and television channels have their web versions. They ensure their web presence in three ways. A. Corporate website of media organization. Web version of the media itself, example verbatim e-version of newspaper in PDF format or streaming audio of radio programs or streaming video of television programs. News portals. dedicated news portals that cover all the news items covered by the media concerned, in addition to web potential materials and content and interaction facility for users who have configuration options. We are now going to discuss news portals. By definition, news portals are websites dedicated to news and designed with customization option for each user. In general, news portals have the following elements: multimedia content, configuration for each user, login system, interactivity and option for user-generated content UGC, response mechanism. Let's move on to detail each of them. Multimedia content. As news portals are dedicated gateways to news world, they use multimedia content unlike online newspapers which give texts and images. Presence of multimedia content increases the usability of the portal and attract more members of audience. On the other end, it makes news gathering for portals complicated since the reporters are to collect audio and video content and to write stories as well. Large-scale news portals give separate session for videos and audios and interlink the video or audio parts with textual stories. However, stories in text are considered primary content and the audio and video contents are auxiliaries or as for more detailed report. Sometimes audio or video content may get preference depending on their role in the story. If the story is worth enough only with video overshadows the textual element. Configuration for each user. Unlike small new websites, news portals offer facility for each user to configure their pages according to their interest. For example, in Google News, we have options to filter our stories according to our areas of interest, including region, sports, business, education, etc. Such an option keeps the audience stick to the portal, eliminating the chances for them to get away to other sites through hyperlinks or while searching for their content of interest. Login system. Most sites which provide serious content to privileged users keep login system. Nowadays, some portals make their content open for all and work as websites. Login system has a number of advantages. The back engine of the portal can keep abreast of the user's pattern of news consumption, and these data can be used later for redefining the news collection and delivery pattern according to users' interest. Also, login system is used as a way of income generation. It is a better option for monetizing content or selling content. There are two levels of login system: partial login or full login. The first one means some part of the content is free and to go beyond some limit, user must log in. In second one, no content is open, only those who log in are permitted to use the content. Usually, login system is attached with user ID and password. Interactivity. Most of the websites are interactive in one or the other way. Interactivity is ensured in various ways. One way is to give options to users to post comments, chat each other, talk back to authors, like or rate content, etc. The other mode of interactivity is to make the content responsive. For example, interactive data visualization, where data is being visible when the user click on the links or buttons of their choice in the data image. One advantage of the interactivity is that there will be option for user-generated content UGC. It ensures audience participation in developing news portal content. This is a boon for news portals which desperate for filling ever-increasing news hole. Also, user-generated contents reflect audience perspectives, which are necessarily multicultural, diverse, creative, and unique. Such an option will make the content attractive and non-biased and make the online journalist more responsible. Some portals offer author emails and chatting facility as part of their interactivity policy. In addition to the above mentioned characteristics, news portals have all other features that we see with online news sites such as immediacy, personalization, universal content, hyperlinking and archivability. And these characteristics demand a different kind of news writing and news presentation for news portals. For a successful online journalist, the features that we already discussed pose an array of challenges, particularly in writing and presenting news. Writing and presenting news for web portals. News presented in portals are formatted in a new writing style which is suitable to web audience. This style has been emerged from journalists' years of experience in handling responses and online behaviors of online news users. Based on this, scholars offer the following tips to budding online journalists who enter into online reporting. Audience analysis. A reporter who writes news for news portals or websites must keep online readers' needs and habits in mind. Web analytics and studies of web usability indicate that web users are not reading news as they do offline news consumption, rather skim over sites or sections of portals. They are more proactive than print readers or radio listeners or television viewers. Their responses and feedback are instant, not delayed as in case of letters to editor, and they simultaneously use multiple news sites and instantly compare the contents. More so, they have unlimited options for fact-checking and verification. Your portal has universal reach unlike local or regional or national newspaper or channel you work for. Hence, online reporters shall write keeping a universal, multicultural, cosmopolitan, educated, advanced audience in mind. Multimedia reporting. In traditional media, we have single option at time, text or audio visual. Online portals carry all these three formats at a time. Before we start reporting and writing story, we have to plan the best way to narrate the story, whether through audio, video, visual data, text, link, etc., or their full or some combination. There is option to collaborate with audio, video and interactive producers. Availability of multiple format complicates online reporting. Only solution is to plan before getting down to reporting and let your plan guide us throughout the news collection and presentation process rather than reporting story and then integrating various elements later as an afterthought. Combine information and emotions. In traditional media ecology, audience members have their own preferences. Newspaper readers prefer information while radio and television audiences look for emotions and pictures respectively. News on web portals must be planned combining these all. Text shall go with pictures and videos combining clear sound. Fault in any of the components may ruin the chance of entire story. For example, blurred video may lead user to skip to other site or story. Hence, maximum preparation shall be made before gathering news for news portals. Dynamic writing. As mentioned earlier, news portals are dynamic and organic and change contents in minutes or in seconds through additions, deletions or modifications. Hence, lively prose leaning on strong verbs and sharp nouns is the chosen style for the web news. Keep your content differentiated from multitude of narratives available online by giving distinctive voice to your story. As said earlier, online users just skim or browse, not read intently, so use conversational and unconventional styles. But grammar, punctuation and collation shall be correct, because news portal audience is global in nature, which includes all levels of people from laymen to experts. Tighter and punchier text. Writing for the web lies between broadcast and print reporting style. The text shall be tighter, punchier than print, but more literate and detailed than broadcast writing. Narrate stories actively, not passively, because your audience is active, jumping from side to the other. Keep them on yours is difficult. easy to grasp texts. Pointer News University document gives the following tips. Use simple declarative sentences. Stick to one idea per sentence. Avoid the long clauses and passive writing of print. Ensure that every expressed idea flows logically into the next. These tips help you write easily and keep your audience attentive. Explain why the story matters. Those who read news on portals rarely notice or care who was first. They want to know just what happened but why it matters. So, write in detail to explain why the news story matters. It doesn't mean that lengthy stories are welcome. Experts say that the maximum length allowed is 800 words, but let that be a guideline, not a rule. Users will stick with lengthier stories online if there is a convincing reason. Don't bury headlines. Story lead is important in news portals since readers are just browsing and leads shall get their attention while they browse. So, you can't afford to bury the lead online. A common problem with online writing occurs in breaking news stories. In an effort to seem as current as possible, sites will often put the latest development in a story at the top, no matter how incremental the development is. Then, they'll pile the next development on the top and the next, creating an ugly mishmash of a story that makes sense only to someone who has been following the story closely all day. The solution is to keep the most important element at top even while covering the latest when updating stories. Avoid large blocks. Don't write stories in news portals in larger blocks. Longer block of text make reading difficult, especially on screen. Solution is to use more subheads and bullets to separate ideas and to keep paragraphs and sentences short. Use multiple elements. You have multiple options to give your news stories with charts, tables, graphs, and so forth. Use these tools to keep your stories attractive and easy to read. Straightforward headlines. Headlines are the gateways in the case of stories in news portals. Users don't know what they are going to get when they click on stuff. And they are not going to click on something unless they know what they're getting. So, give straightforward headlines that lead users to exact content. Studies show how online news users preferred straightforward headlines to funny or cute ones. Cute headlines didn't do as good a job of quickly explaining what a story is about and thus discouraged online users from clicking through. Use hyperlinks with reason. Hyperlink is a basic feature of websites and portals. You can link your stories in appropriate ways considering their connection. Sometimes you need to link your story to other sites. Online journalists have a paranoid fear that if they include links to other sites, readers will surf away and never return. It is not true. If your portal and its contents are good, they must return and enjoy yours. The above mentioned are useful for those who wish to write and present news in news portals. I recommend you to look into some of the professionally managed news portals from India and abroad. It will help you understand how a successful port functions and how their contents are created. Let's summarize. In this session titled News Portals, we have defined portals as dedicated websites which function as gateways to a particular area or sector with configuration option for each user. News portals are websites dedicated to presenting news stories in multiple formats and ensuring customization and interactivity options for their users. After detailing the characteristics of news portals such as multimedia, login system, configuration, interactivity and response mechanism, we shared the tips and tricks used for successful writing and presenting news stories for news portals. We learned that the stories shall be crispy, updated, punchier and tighter than that for traditional media like television, and shall be in conversational style and in multimedia format. These all are keeping in mind that online journalism and its users are ever changing and are demanding refined and innovating approaches in content creation and delivery. You try to answer a few questions now. What are the major types of web portals? What are essential services of web portal? What are the elements general news portals? What are the things taken care of writing for web portals? You may go through a few references for further reading. The Digital Reporter's Notebook, Reporting with Online Media by Mark Blaine, Routledge, New York, 2013. The Online Journalism Handbook, Skills to Survive and Thrive in the Digital Age by Paul Bradshaw and Lisa Rohuma, Pearson, England, 2011. Writing for Digital Media by Brian Carroll, Routledge, New York, 2010. Journalism Next, A Practical Guide to Digital Reporting and Publishing, 2nd edition by Mark Briggs, CQ Press, Washington, 2012. Digital Innovations for Mass Communication, Engaging the User by Paul Martin Lester, Routledge, New York, 2013. Hope today's session was enriching. Thank you for watching today's program. Goodbye.
Welcome to the Interface program. Today we have Professor Ajit Kembavi as our guest. He is a world-renowned astrophysicist. He has been involved with many mega projects in astronomy. And welcome, Ajit.
Nice to talk to you today.
Yeah,
I'm very glad to be on the Interface program.
So, will you be able to elaborate a little bit about the mega projects that?
Yes. We have been hearing a lot about mega projects in astronomy in India. So first we'll see what are the mega projects. As you know, astronomers are very fond of building bigger and bigger telescopes. So the idea is that a bigger telescope, you can see much further in the universe. We should also mean that because of the time taken by light to travel the great distance, it means that you are looking at the universe in the past. So when we observe distant objects, we not only see how the universe is now, but we also see how the universe was millions, hundreds of millions and even billions of years ago.
So, what is the biggest telescope now we have in India? Or what
yes,
is the yeah.
What happens, let me just complete what I said, was that because of this need to build bigger telescopes, the programs are getting bigger and bigger, the telescopes are getting more and more expensive, and they require a very great deal of technology, which should mean that many people in many countries have got to cooperate together, and the cost becomes very high. So a project like that, where you spend hundreds of millions of dollars, or in our language, many thousands of crores, and where there is a lot of people involved, and where the time scale is long. Okay, which means that it will take you 10 years to build the telescope, and then you'll use it for the next 20 years or so. Okay. That is typically what is called a mega project in astronomy.
Okay. So coming back to the telescopes, what is the status that India has now in terms of the size of telescopes, for example?
Yes. Now that is a very interesting question. because the answer can become very complex. Because first of all, I should ask you, what do you mean by a telescope? Because the traditional view of the astronomer is that he builds a telescope, optical telescope, and looks at the stars through the lens and sees the stars. Now, that view is no longer tenable for two different reasons. One, even optical telescopes are very large. They are reflecting telescopes, which means that you use a mirror rather than lenses. And then, because of their size and their excessive complication, you need computers to drive the telescope. Number one. Number two is that the electromagnetic wavelength region that astronomers used to observe is very wide. So it would mean that there can be radio telescopes. A radio telescope is just like the antenna that you have on top of your house to detect signals from satellites for your TV, except that they can get much bigger, and they can be tens of dishes which act together. Or you can have a X-ray telescope. X-rays don't penetrate the Earth's atmosphere and reaches from distant sources, and therefore X-ray telescopes are always put on satellites. So depending on which part of the spectrum you want to observe, there will be different telescopes. In modern astronomy, we always take a multi-wavelength approach, which would mean that we use many different kinds of telescope to observe the same object and get a spectrum.
Okay, because when you said this multi-wavelength observation, our satellite, the first astronomical satellite, AstroSat, is known for its capabilities now. According to you, how is it going to help the astronomy community here, or what are the advantages of having a telescope like that in space?
That is a very interesting question that you ask as soon as I mentioned multi-wavelength observations, because AstroSat is a very fine example of this approach. Traditionally, what happened was that people had, let's say, X-ray telescopes on one satellite. So let us say that they observe very interesting X-ray source, but they want to observe it at other wavelengths. They would have to depend upon other telescopes. And now that kind of organization is very difficult to bring about quickly, which would mean that if I observe a cosmic source in X-rays at one time, by the time I went and observed it in the radio or in the optical, it would be several days later, which would make it unusual. The data then is not the best possible. Well, AstroSat is the first Indian satellite fully dedicated to astronomy. It was launched on September 28 last year. It has been in the making for a long time. Now, AstroSat is a very important addition to the world of astronomy, because first of all it is a multi-wavelength satellite, which means that it has got 4 telescopes, each of a different kind on it, which all point in the same direction. There is a 5th sky monitor which is perpendicular to them, but these 4 observing telescopes are they're pointing in the same direction, which means that a given source can at once be observed in the optical, in the ultraviolet, in the soft X-rays, in the hard X-rays and very hard X-rays. So that makes it a very unique satellite. There have been no satellite so far anywhere in the world with such a capability. Second, AstroSat has also large detectors, which means that you can observe sources very quickly, which means that one can follow the time variation of these sources very fast.
So, just like you were mentioning in your talk, the 30-meter telescope is also another big project that India is getting involved into. So, will you be able to elaborate a little bit on that?
I can tell you about 30-meter telescope, but let me first tell you about what is the kind of observing facility we have in India and abroad. Now, we have several telescopes in India of the 2-meter class, optical telescopes. So, one telescope is belongs to Ayuka, my institute, and which is near Narayangaon, the telescope. And then there is another telescope belonging to the Indian Institute of Astrophysics, which is in the Himalayas in Hanle. And then a 3.6 meter telescope, which would be the biggest, one of the biggest telescopes in Asia, is about to see first light in the Himalayas. It belongs to Aries. But then these, by present day standards, are counted as relatively small optical telescope. So what is a big telescope? I can mention 2 telescopes to you. One is actually a pair of telescopes, the Keck telescopes, which are located in Hawaii. They belong to Caltech and University of California system, Each telescope is 10 meters in diameter. I mean, which makes it the biggest telescope in the world. There is another large telescope with which we Indian universities and IUCA have an association, and which is called SALT, which stands for Southern African Large Telescope, which is 400 kilometers away from Cape Town in a very, very remote region. Okay. So these now count as the biggest optical telescopes. So that you mentioned 30-meter telescope. You see, the 30-meter telescope has the number that you use. When I say 2 meter, or when I say 20 meter or 30 meter, that always refers to the diameter of the mirror. Now here is another interesting fact which comes about. Typically the lenses and mirrors which are associated with telescopes so far have been circular. Because why circular? Because they are easy to make. But as telescope mirrors became bigger, it became impossible to make a monolithic mirror of 10 meters, let alone 30 meters. And even if you make the mirror in your factory, how will you carry it? Hardly any road anywhere in the world will allow you to carry a 10-meter object up the mountain. Now astronomers make segmented telescopes, okay, which means that you construct the mirror out of much smaller hexagonal segments. You stick them together. So which means that the whole mirror, the large mirror, has got the shape of a hexagon. So the 30-meter telescope is built like that, and if you go from one corner of the hexagon to another corner of the hexagon, it will be opposite corner, it will be 30 meters. What is important is not the diameter of the telescope, diameter of the mirror, but the area of the mirror. So now I got a 10-meter mirror, then I got a 30-meter mirror, the new one, which would mean that the area, the diameter is 3 times bigger, which would mean that the area is 9 times bigger. And so which means that the capacity of that telescope to observe is 100 times, 10 times better than the existing telescopes.
Yeah. So the complexity just not depend on the size, and it increases in every manifold, right? Because the moment we put different number of segments, the arrangement and their accuracy that we have to achieve all becomes really complex.
So you see, again, that is a very important consideration that you raise, because just imagine how big is a 30-meter telescope, and 30 meters is a football size thing, and then you go there, and so now that telescope is not static. Okay, it is that mirror has to be made part of a machinery so that you can point it to any direction in the sky, and you want very, very accurate pointing. The surface of the telescope again has to be extremely accurately defined. So what happens is that even if you take a telescope with a single mirror, as you point in different directions, the gravitational forces on it, the stresses act differently, which actually bends the mirror slightly, distorting image. But now the modern telescopes are segmented, meaning that, as I explained to you already, you are taking small segments and then you are arranging them together into one large mirror, which means they can go out of shape. So you require a technology which is known as active optics, meaning that there are sensors on the mirrors which can all the time sense, once every second or quicker, they sense the relative positions of the mirrors, and then there are assemblies behind the mirror which allow you to move the mirrors slightly up and down. The mirrors can be moved in 3 directions so that you have the perfect alignment. Now aligning the mirror is just one thing. Now the instruments, because the telescope is only an agent, the telescope, it actually funnels light onto the mirror and onto your instrument. But then what you need to do is to have a detector. In the old days, the detector was the human eye. About 150 years ago, people started using photographic plates. But now these are electronic detectors. I mean, these are CCD detectors, okay, so with which everybody is familiar now because they're the cameras and so forth. So what happens is that you use these kind of instruments, but the larger the telescope, the larger is the instrument. So for the 30-meter telescope, each instrument is of the size of a large hall, you can say.
Yeah.
And therefore, controlling all these instruments, putting them together, controlling the telescope, it becomes a gigantic information technology problem.
Yeah.
Okay, so for the TMT, for example, because India is a very important contributor to the software development for the TMT, which is for the control of the telescope as well as all other tasks, and it is going to take 10 years to write that software.
Yeah.
Okay, so therefore the telescope is a very, very complex machinery, and to keep it going flawlessly is incredibly difficult.
Type of technology that we need is really vast now.
It's vast, and you can say that much of the technology that you use will actually be frontier technology. Okay, because you see, the point is that we are building the biggest telescope in the world of its kind. So, which would mean that the technology is something which has not been tested before. Okay, because this telescope is bigger than anything that you have, and you know, scaling is not always very easy, because if I make a model toy plane and I make it very cleverly and I can get it to fly, then it does not mean that I can just multiply everything by 100 and make a passenger plane, because when I make the telescope, the plane bigger, then I have to consider completely different aerodynamics. Okay, so similarly, when I make a bigger and bigger instrument, there will be unknown effects which come into the picture. But that is a challenge which drives all the scientists and all the technologists, because what we understand is that unless there was something new to be discovered, then people would not be interested.
Professor Kimpavi, can you please say about our ventures or our efforts into these international things in, say, in the TMT?
See, as I told you, the TMT is the international collaboration. It was started by the Americans, Caltech and University of California, and it is supported by the Moore Foundation. And it is interesting that this Moore is the same one who gave Moore's law, with all the people in computer science are familiar with. So he gave a lot of money for it. And then later, Canada and Japan, China and India have joined. So India is a partner at the 10% level. So what it means is that we contribute 10% of the total cost of the telescope for building it and then for maintaining it. But this is not a case where we send all the money abroad and they use it in whatever way they like. Much of what we are contributing goes as a material contribution. Okay, which means that we will design the software, we make some of the instruments, we polish some of the mirrors, and there are several such activities that we carry out, which gives us wonderful experience. So we should mean that at the end of the program, when the telescope is ready, Indian astronomers and engineers will be capable of building their own large telescope.
Okay, even larger ones.
Now, how do we do it in India? This is the national effort. There are 3 institutes: the Indian Institute of Astrophysics in Bangalore, and Ayuka in Pune, and Aries in Nainital. These are the 3 principal partners. The coordination center will be in Bangalore at the IIA. But then there are so many other institutes and organizations and also universities which are helping with it. So once the telescope is built, then there will be a national committee which will call for applications for time, and then that telescope, the time allocation committee, will actually take into account the merit of the proposals which have been made and allocate time. So, and then the data which is obtained will be with the proposer for 2 years, after which it will be made public. Okay, which would mean that all the good things which come from the telescope will be easily accessible by any person in India who wants to use that data, and it will be fully available nationally.
Then coming back to you were involved with the virtual observatory program in India and in the international arena also. So can you please tell about
So what is the virtual observatory?
Yes.
I talked at length about what is the telescope, and so an observatory is an organization and a setup which has got the telescope and all the other equipment which is required to use it, to maintain it, and many observatories have more than one telescope, or what I would call a hardware observatory, meaning that you will actually go there at the top of a mountain usually, and then you will see all these telescopes there. But for the last dozen years, you have had a concept which is called the virtual observatory, and or the VO, and the virtual observatory provides the same facility that an observatory does, except that it does not, you cannot take new data with it. But as I already said, all data which is obtained through important telescopes is archived. Okay, and then it is generally made available freely to all astronomers in the world. So the virtual observatory allows you to develop standards to be able to use the data. It allows many applications so that you can, these are vast quantities of data, hundreds of terabytes. So you are enabled to actually manage the data and to use it and to analyze it. So it is very interesting. But there have been cases where people sitting in some, let us say, rural parts of Kerala or deep in Assam or Arunachal Pradesh. From normally communication is difficult, for them to come to Ayuka is difficult, but because of the internet, which is now universally available, they can use the internet to access virtual observatory facilities. Meaning, what do I mean by that? I can say that, look, here is a list of 10 astronomical sources. Can you give me all optical data that is available for them? You can put this query in, it is in a technical language which is very easy to learn, mostly web-based, and quite soon, meaning that depending upon how much is the data, within seconds, or sometimes if the data is very voluminous, within hours, you will get the data. You will not only get the data, you will also have all the tools to analyze it. So which means that this empowers everybody. It is a wonderful concept.
Even observing the sky without a telescope at all.
Yes, but you must not. If there were no telescopes, there will be no virtual observatory. Because you observe, you get the data, you put it together, and so because you see the important thing about a given data is that it is not there for single use. Okay, meaning that just think of a cup of tea. A cup of tea is a single use thing. Okay, because I drink it and it is gone. Alright, so whereas data is not single use, because you may want to use the data for some purpose. I can use the very same data for a different purpose. Okay, so that is the idea behind a virtual observatory.
Okay. So this in radio also we are getting into a new project, the kilometer array. SCA.
Yeah. So
what is our role in that?
Yes. You see, the radio astronomers cannot use a single telescope. That is because the wavelength of radio waves is very large, and we should make a good radio telescope prohibitively large in size. So radio astronomers have solved that problem by breaking up, instead of taking many small telescopes and using them in phase. It's a very complex technology, so that they can have the same action as having one large telescope. Now there is a GMRT which was built by Professor Govind Swarup of the Tata Institute of Fundamental Research. It is now managed by the National Center for Radio Astrophysics in Pune. So GMRT is one of the world's biggest telescopes of radio telescopes of its kind. So just like the TMT will be bigger than everything else when it is built, apart from the ELT. So there is a new radio telescope being built, which is called the SKA, Square Kilometer Array, because the total collecting area will be equivalent to 1 square kilometer. And this telescope is being built in two parts. One part will be in South Africa and the other part will be in Australia. So why these two countries? Because they have sufficient remote regions. In India it is very difficult to get a remote location, because even though our country is very large, there is a population, there is a growing population, and there is economic growth, okay, which means that it is very difficult to get empty areas. So now the SKA will have a very large number of antennae. It will be a very large telescope, and India is again an important partner of this project, and the activity is coordinated by NCRA in Pune, and NCRA is also building the telescope control system for the telescope. This will be ready partially in 2020, when you can start using it, and 2024 I believe is the target date for a certain level of completion.
Okay. Another interesting area where India is now getting into is the gravitational wave detection.
Yes.
So what are the chances of getting such a facility in India now?
If you ask me what are the chances of detecting gravitational waves, I can give you the answer, but if you ask me what is the chance of the project being approved, I cannot, because it has been with the government for a long time. But it is very interesting that the primary idea, due to Albert Einstein, the general theory of relativity on which all this is based, celebrated 100 years. It became 100 years old just last November. So Einstein gave this very revolutionary theory. Everybody has heard of Albert Einstein, everybody has heard of his theories, the theory of relativity, and there he said that gravitation manifests itself through changes in the space-time structure. And one consequence of his theory was that gravitational waves should exist. So what do you mean by that? you see that electromagnetism, electric and magnetic fields acting together, are described by what are called Maxwell's equations, which are the mathematical, which constitute the mathematical theory of electromagnetism. A consequence of Maxwell's equations is that electromagnetic waves exist, and electromagnetic waves are very, very important. For example, right now you and I are talking together through the medium of electromagnetic waves, because we are using microphones, we are using amplifiers, and our talk is being recorded. Okay, so just as electromagnetic waves exist, it is believed that gravitational waves also exist, except that they are extremely weak. They are so weak that if I take two electrons and I consider electrons, as you know, are charged particles, so there is a Coulomb force between them. That Coulomb force is roughly 10 to the 40 times the gravitational force, so which tells you how immensely weak gravitation is. So how do you generate electromagnetic waves? Okay, you generate electromagnetic waves by taking an antenna and putting up. Like if you look at the local Vivid Bharati station, it will have an antenna, and then the program and electromagnetic signal is sent to the antenna, and which is broadcast. Right. So what is the source there? The source is our voice, which drives something, and then it is amplified and put up the antenna. Now the source of gravitational waves are massive objects, except that the gravitational waves that you and I can produce will be utterly negligible. So we depend upon very massive, very compact objects like neutron stars. And if there are two neutron stars going around each other, then they will produce gravitational waves, especially and when they produce the gravitational waves, they lose energy, therefore they spiral together, and as they spiral they produce more and more waves. Right, so then you get a burst of gravitational waves from them. Now these gravitational waves, detecting them is very difficult, and you do that by building what is called a very vast interferometer. Okay, this interferometer, the one which I use called there's an experiment called LIGO, Laser Interferometric Gravitational Wave Observatory. So LIGO is located in the USA. There are two LIGO detectors, and over the last 6 months people have started deploying what are known as advanced LIGO detectors. Okay, so which are very much more sensitive than the original ones, and these act in tandem together. So now the idea is to build a third LIGO detector in India, and it will be a collaboration between the American and Indian groups. The American group has given the immensely sensitive LIGO detector, and it will be the job of Indian astronomers and engineers and physicists to actually build a very large vacuum setup. So the setup is that there are two arms which are 4 kilometers long, and then they are held at very high vacuum. Inside them is one of the most powerful lasers in the world, and these lasers are reflected by mirrors, and then interference pattern is produced. Okay. So when a gravitational wave passes by, it changes the pattern, which allows us to detect it. All of this sounds very familiar because it is what is known as the Michelson interferometer, except that the signal here is incredibly weak, and the length change that the signal produces is an extremely small fraction of the size of an elementary particle like the proton. Okay, so which means that you cannot use normal technology, and people have been trying for very hard, and everyone believes that now we are on the verge of success.
Okay. Why they wish to have the LIGO in India rather than in putting in another place of the world, because they have already.
One thing, the most important reason is that India is very far away. So you see that the two detectors in the USA, there is one which is located in Washington state in the northeast of the US, northwest of the US, whereas the other one is located in Louisiana in the south, and they're located far away because the greater the distance, the more sensitive it will be to the direction from which gravitational waves are coming. So if you follow the same logic and you put a telescope in India, a gravitational wave detector in India, then you will get a very long baseline. Now you could put it in other countries, but there are two important requirements here. One requirement is that the country must itself be technologically advanced enough in this subject, right, so that they can build part of the detector and part of the installation and the whole of the installation, and then they can also they have the technology to to actually operate it. Whereas there is one requirement. The other requirement is that this is a mega project. It needs a lot of money, and it's very important that the government takes into cognizance the importance of it and approves the project and gives you funding. And because all these circumstances seem to be available in India, therefore there is LIGO India.
Okay. With these mega projects, how the students can get into astronomy and astrophysics, or the long term, how beneficial will it be for those people?
Again, you are touching a very important point here, because it is going to take more than 10 years to build any one of these big things, and then they are going to be operated over 20 years. So which means that people who will use them are just about being born. Okay, one. And second, the last people to use it are just being born.
Yeah.
The first people to use it will be those who are now 20 years old and 25 years old, and it is those people that we have got to train and we have got to educate to use them. Now you see, the point is that if you offer a student to work on something which has been there for a long time, and now we all have telescopes, so you have a telescope, we have a telescope. When you have these kind of things, students do come because they are attracted. But just instead of asking them to work on your small telescope, let us suppose that you say, do you want to work on the world's biggest telescope? I mean, that has got a completely different kind of attraction. Okay, because first of all, the challenge of working with something which is the biggest in the world, and secondly, the interesting investigation that you will make. So that is why there is a concept of astronomy for development, meaning that I am not talking about the development of astronomy, I am talking about astronomy being used as a tool for development. Okay, so how does that come about? Because making big telescopes involves new technology. Many people get trained in it. Young students will use it, and therefore the overall economic development and scientific development of the country. So therefore it is going to be our endeavor to teach young people, to bring them into this fold and to encourage them to use these big telescopes.
So it was wonderful talking to you, Professor Kembavi. Let me thank you for your valuable time and your talk here.
It's been a great pleasure for me. Thank you very much.
In today's session, we shall discuss Cartesian method. Every domain of knowledge, may it be religion, science or philosophy, is marked out by its specific method or methods. A method is the starting point and guiding light to verify the soundness of all previous knowledge and to attain further new knowledge in a certain area of study and investigation. In Chayarai's book, Studies in Philosophical Methods, method is defined as the way in which fruitful starting points and procedures are determined. As we know well, scientific method has its definite starting point, namely the data collected by the empirical methods of observation and or experiment. But it is not possible to assume the same starting point in the case of philosophical studies, because its basic component, namely metaphysics, is not a scientific discipline, as it transcends all apparent phenomena to seek what is essentially and invariably present in one and all phenomena. As A.J. Iyer points out, philosophy is to be distinguished from other sciences not by its subject matter but by its method. The turning points in the history of philosophy are marked not only by the disputing positions of philosophers but also by the different methods they have adopted. Thus, there are dialectical, logico-mathematical, analytical and phenomenological methods used by different philosophers in different times. Today in this session we shall consider the method introduced by the great French philosopher René Descartes. His lifetime is between 1596 and 1650. His method is relevant in philosophical inquiries even today. Cartesian method is distinguished as the logico-mathematical method that he prescribed as necessary for philosophical inquiries also. Descartes is regarded as a founder of modern Western philosophy, as also of modern continental rationalism. He regarded philosophy and its method as crucial to the human pursuit of knowledge. It is clear from the Cartesian view. He says, thus philosophy as a whole is like a tree whose roots are metaphysics, whose trunk is physics, and whose branches which issue from this trunk are all other sciences. Descartes is regarded as a founder of modern Western philosophy with Francis Bacon, as also of modern continental rationalism. He regarded philosophy and its method as crucial to the human pursuit of knowledge. It is clear from the Cartesian view, as he says, thus philosophy as a whole is like a tree whose roots are metaphysics, whose trunk is physics, and whose branches which issue from this trunk are all other sciences. Descartes' famous work, The Discourse on Method, carried out his attack on the scholastic method based on the authority of sacred texts of the Catholic Church. His aim was to find out and establish the possibility of discovering truth without the help of some external authority, for example, the holy books and the clergymen. Thus, thought or reason, as the innate faculty of every individual human being, is the center and sanction of the whole of Cartesian rationalism as well as the Cartesian method. That is why E.W.F. Tomlin observes, the discourse on method is the charter of scientific humanism. Now we shall come to the basic tenets of Cartesian method. An easy way for this is to begin with his famous aphorism cogito ergo sum, which means I am thinking, therefore I exist. This famous dictum of Descartes implies a reversal of our common sense understanding that recognizes existence as the precondition or the preceding condition of all life activities, including thinking. And how Descartes proves his cogito principle is also the finger post to understand the technique and goal of Cartesian method. But before coming to the technique involved in the method of understanding unfolding philosophical truths, we shall see what the method aims at. We have already mentioned that his criticism of the scholastic method focused on its failure to arrive at certainty in knowledge. Descartes opined that different scholastic thinkers had held different views on the same subject because their epistemological foundations were precisely unstable. Hence, Descartes challenged the reliability of scholastic method and developed his own method that served the following goals. Now we shall see the goals of Cartesian method one by one. First of all, Descartes insisted that we should aim at acquiring a body of certain and self-evident truths. Here you have to see what is the precise meaning of self-evident truth. In philosophy, especially in modern Western philosophy, Descartes and Kant had conceived something that we term pure thinking and pure conditions of knowledge. So when we say that a certain piece of knowledge is self-evident or pure, it means that that piece of knowledge does not require the epistemological support of any other piece of knowledge or judgment except that principle or truth itself. Secondly, Descartes emphasized that one should not depend upon the opinion of others, but always depend upon one's own thinking or one's own reasoning is the Cartesian way. And third is that according to Descartes, mathematics provides us with the model of indubitable, that is again self-evident propositions. And finally, the criterion of certain knowledge is that it should be clear and distinct. And before coming to a detailed discussion of these points, it is necessary to note Descartes' strong interest in mathematics, and this had been the case with other prominent modern thinkers like Leibniz. Descartes had chosen a career in the Dutch army before becoming known as a philosopher. He had a short spell of career in the Dutch army, which gave him the opportunity to apply his mathematical interests for solving the problems in military engineering. And in Holland, Descartes could establish friendship with the great Dutch mathematician Beekman, to whom his essay on algebra was dedicated. This is the intellectual background of Descartes' emphasis on mathematics as the model of certain and self-evident propositions, which we call axioms of truth. And this term axiom of truth is very crucial to understand Cartesian method and Cartesian epistemology. Descartes had insisted on a project of human knowledge that would ensure a system of thought with mathematical certainty and precision. This should be the case of all types of knowledge, may it be scientific or philosophical. According to Descartes, only the mathematical method is completely free from authority, because no authority shall disprove the truth of mathematical axioms. And we shall demonstrate this Cartesian emphasis on mathematical method by taking an example. We all know that it is not possible to deny the truth of the mathematical principle that the sum of any two numbers will be higher in value than the given numbers. And similar is the case of the geometrical axiom, which we all know well. The sum of the angles of a triangle is equal to two right angles. And such indubitable and indisputable propositions are the axioms upon which the strong edifice of mathematical knowledge is built. So far we have seen that Descartes had a strong inclination to prove that the mathematical axioms are self-evident and not affected by any empirical considerations. Now Descartes wanted to extend this reliable method of mathematics into the domain of philosophy also. It was, as he believed, necessary for liberating philosophical thinking from its conventional skepticism. Most of the disputes and errors in philosophical knowledge, Descartes argued, are due to the lack of a sound axiomatic foundation. Philosophers should therefore explore into the absolutely certain first principles. I stress the word first principles because they are very crucial to understand the goal of Cartesian method. And these first principles are ever beyond doubt and error because they are, as we have already shown, self-evident. Descartes' project to acquire such clear and self-evident propositions as the basis of philosophical reflection is the core of his method, which we consider as Cartesian method. The procedure, therefore, is to apply reasoning to discover the basic axioms of knowledge before we proceed to acquire more and more knowledge in any area of study. So, axiomatic truth or knowledge is the foundation of all further knowledge that we consider genuinely true. Descartes insisted that our search for knowledge should not be based on random steps, but on a definite methodological procedure. In his famous work, Discourse on Method, Descartes had prescribed the 4 rules of his method. First one is, before accepting anything as true, it must be known to us clearly and distinctly. So, clarity of knowledge is the criterion of the truth of knowledge according to Descartes. The step is to divide each problem, any complex problem, into its necessary simple parts. Then direct our thoughts in an orderly way from simple to complex and explain them in an orderly way is the Cartesian method. It is necessary to make a complete enumeration of the problem without omitting any component. So, we should consider the total system of knowledge before deciding its truth or falsity. We shall consider the starting point of Cartesian method. How to begin the method is our concern here. The starting point of Cartesian method is deliberate doubt. Doubt, all that can be doubted, is the Cartesian way. But when we take the Cartesian concept of doubt, we should make clear that it does not mean skepticism. That is, skepticism in philosophy is the position that doubts the very possibility of true knowledge. But Cartesian skepticism or Cartesian doubt is not exactly philosophical skepticism. It is not psychological doubt, but methodical doubt. Doubt is the beginning of reasoning process that leads us to indubitable certainty. So, in the Cartesian context, understand doubt as the path to indubitable certainty or absolute certainty beyond any doubt. So, doubt is the starting point that leads us to any truth that is not indubitable. In the world of experience, sense experience for example, we come across many illusions and hallucinations. Different people experience things differently. Hence, the truth of sense experience is always probable and changing. This is a fact that we all accept. And it is the case with imagination and customary beliefs also. Here, Descartes follows Plato in elevating reason to the status of the most reliable path to genuine knowledge. That is why we say Cartesian system is, or epistemology is, rationalism, because he recognized reason as the only reliable path to genuine knowledge, and in this case Descartes had strictly followed Plato's spirit of idealism. However, there is a difference between Plato's concept of reasoning and Cartesian concept of reasoning. Plato had conceived dialectical reasoning as a power to be acquired by a gifted few through hard practice. So, it is reserved for a gifted few who have that capacity for acquiring rational knowledge. But for Descartes, reasoning is the innate power common to all sane minds. That is, every human being deserving the title human being is innately, naturally rational, and therefore is capable of rational thinking, is the Cartesian position. Descartes had prescribed specific rules for the direction of human mind. Here we shall consider the third and fourth rules for the direction of human mind, which explains intuition and deduction as the ultimate source of indubitable knowledge. We must try to understand the specific connotation of intuition. Intuition in epistemology is the primary source of all self-evident knowledge acquired immediately. I stress the word immediately, which means without the medium or aid of sense perception or authority or any other source other than reasoning. So, it is the unclouded mental attention as Descartes defines it. From the axioms we understand by intuition. Now, we can draw further necessary conclusions. So, actually Cartesian method is combining intuition, which is the way to grasp axioms of truth, and from this intuition or this axiomatic basis of knowledge we can draw further necessary conclusions by deduction. Hence, Cartesian method insists on the epistemological foundation of intuitively acquired axioms of knowledge for deriving true conclusions by deduction. Any knowledge without this foundation of axioms is always liable to be false. Now, at this point, we can summarize the characteristics of Cartesian method. First of all, the foundation of Cartesian method is axiomatic, that is, intuitive knowledge. As I have told you, the pure knowledge, any knowledge without the constraints of sense perception, that is, pure intuitive knowledge of axiomatic truths is the basis and source of further deductions. So, the starting point is intuitive reasoning. Secondly, the model of Cartesian method is mathematical knowledge, that is, the propositions of arithmetic and the axioms of geometry are self-evident and they need no proof. Then, the technique of Cartesian method is rational intuition, that is, the reasoning power of human mind, which is innate, is the means to grasp axiomatic truths because it is free from the limitations of sense perception, authority and any other customary means to acquire knowledge. That is why we call them pure axiomatic self-evident knowledge, which Descartes declared as clear knowledge, distinct knowledge. Now, it is clear that mathematical intuitions are axiomatic. We have already shown how Descartes had proved their purity, and now Descartes could extend this principle of axiomatic truth into the domain of philosophy. That is why we consider Cartesian method, even though it is termed logico-mathematical method, we consider it as applicable to philosophical problems in the domains of metaphysics, epistemology, etc. Here we consider mainly Descartes' cogito principle and causal argument for the existence of God to demonstrate the application of Cartesian method in metaphysics. So, the most important thing is to understand the implications of the famous Cartesian dictum cogito ergo sum. As we have shown, it means, by translation into English, we can see that it means, some people say it translates it as I think therefore I exist, but most precise translation is I am thinking therefore I exist. Now, this cogito principle becomes the axiom of all human reasoning according to Descartes. Now, we shall analyze how he proves it. How do we understand the proposition I am thinking? My question is, how do we understand the proposition? By what means we grasp the proposition I am thinking? Sure, not by sense experience. There is no need of any medium other than thinking to grasp the judgment, and hence it is immediate and self-evident truth. You just consider a person thinking that I am thinking. Nobody can dispute it. It is as true as the mathematical proposition 2 plus 2 is equal to 4. So, Descartes proves how the metaphysical axiom of cogito ergo sum is logically equivalent to the mathematical propositions like 2 plus 2 is equal to 4. In Descartes' own words, he says, cogito ergo sum is the first and most certain knowledge that occurs to one who philosophizes in an orderly manner. Like the axiom of cogito, the core of Descartes' proofs for the existence of God is another intuitive judgment, namely the principle of causality, which we consider as a law of nature which we understand by intuition. According to Descartes, one of the innate ideas in human mind is that of God. It needs no further proof because we know intuitively that nothing can come out of nothing. This is called the principle of causation or the law of causality. Descartes argues that my existence as a thinking being is self-evident, which he had already proved by the cogito principle. And I cannot come into existence without a cause that precedes my existence according to the law of causation. God is therefore that eternal and perfect being of all beings, including myself. Descartes argued that such a perfect being must be self-caused. It cannot have another thing as its cause, that is, God is self-caused, uncaused. Because if it is not the case, suppose God has a cause, logically we have to admit an infinite regress in conceiving causality. So if we argue that I have a cause and that cause is God, and therefore God has a cause, you have to search for God as the cause of me, then you have to search for the cause of God, and further the cause of God, it goes on infinitely, which is a logical fallacy called the infinite regress. In order to avoid this infinite regress, Descartes argued that God is intuited, and that intuition of God is the intuition of a self-caused being of all beings. And this causal argument for the existence of God is based on the axiom of causality, according to which nothing is uncaused or everything is caused. And Cartesian method is even today recognized as valuable and fruitful in our search for truth in any area of study. For example, his emphasis on clarity and certainty of knowledge as the benchmark of truth remains the ideal for scientists and philosophers alike. In all the areas of knowledge we consider, truth depends upon, or truth can be communicated only if the expression of knowledge is clear and distinct and certain. So it remains the ideal, epistemological ideal for all scientists and philosophers even today. Another important feature of Cartesian method is his rejection of authority as the standard of truth. Certainly it is the motivation to doubt any piece of knowledge until it is proved on the basis of the axioms of truth. For example, in physical sciences we consider the laws of nature as axiomatic, and we have already stated that mathematical propositions are the model for axiomatic truth. Anyway, critics of Cartesian method have questioned the validity of applying mathematical method to all other disciplines. Many critics argue that philosophy is not a mathematical discipline, hence it is not proper to apply mathematical method to a discipline like philosophy. And we have seen that Descartes had begun his philosophical inquiry from the intuitive certainty of cogito which is not at all doubted. But Descartes, like any other rationalist, idealist thinker, could not establish the existence of pure thinking without reference to objective reality. A thinking mind is always in a body, and a body is always in a world. So, we cannot actually recognize some piece of thinking or knowledge as pure or free from empirical considerations. Anyway, in spite of all these objections and criticisms, Descartes certainly remains one of the great methodologists in the rank of Socrates and Aristotle. You can try the following assignments. First one, define method and bring out its significance in science and philosophy. Second, evaluate the contribution of René Descartes in developing a philosophical method. Third one, bring out the characteristic features of Cartesian method. And fourth, describe how Descartes' interest in mathematics had influenced his philosophical method. The important reference books are A.J. Ayer's The Revolution in Philosophy, published by Macmillan, and there is a textbook by Abhijit Kundu and others. The title is The Humanities, Methodology and Perspectives, and the basic text will be Chaya Rai's Studies in Philosophical Methods, published by Jabalpur University. And you can also try A History of Philosophy written by Frank Tilly. The specific pages are from 303 to 307. You can also see Tomlin's book Philosophers of East and West. Again the pages on Descartes from 350 to 355. And we shall see some useful websites that deal with Cartesian philosophy and the Cartesian method. You can get the article entitled The Cartesian System on Britannica.com. Then there is an article, Descartes' Life and Works, which you will get on the online encyclopedia, Stanford Encyclopedia, available at plato.stanford.edu. And there is a very good article by Broughton. Title is Descartes' Method of Doubt, that is available on Princeton Education site. And philosophypages.com has an informative article, Descartes, A New Approach. And there is another one on philosophy.tamu.education entitled Descartes' Methodic Doubt. And a very useful article is available in the Internet Encyclopedia of Philosophy, René Descartes' Scientific Method. Thank you for listening to this session.
Hi friends, In the previous session, we have discussed about continuity and derivatives. Now, we discuss about Cauchy-Riemann equations. That is, we are going to obtain a pair of equation that the first order partial derivatives of the component function u and v of the function fz is equal to uxy plus ivxy. This must satisfy at a point z0 is equal to x0 y0 when the derivative of f exists there. We also show how to write f dash z0 in terms of those partial derivatives. So, first we have Cauchy-Riemann condition theorem. First one, we have necessary part. Suppose fz is equal to uxy plus ivxy and that f dash z exists at a point z0 is equal to x0 plus iy0. Then the first order partial derivatives of the functions u and v must exist at x0 y0 and they must satisfy the Cauchy-Riemann equations ux is equal to vy and uy is equal to minus vx. Equation number 2. Also, f dash z0 can be written f dash z0 is equal to f dash z0 is equal to ux x0 y0 plus ivx x0 y0. That is equation number 3. The equations in 2 are called Cauchy-Riemann equations. So, named after the French mathematician A.L. Cauchy, who discovered them, and also in honor of the German mathematician G.F.B. Riemann, who used them in his theory of functions of a complex variable. Equation 3 provides a formula for finding f dash z0 in terms of the partial derivatives. Proof. Suppose that the derivative f dash z0 exists. We write z0 is equal to x0 plus I y0 and delta z is equal to delta x plus I delta y, and of course delta w is equal to f of z0 plus delta z minus f of z0, which is equal to u x0 plus delta x y0 plus delta y that is u x0 plus delta x y0 plus delta y minus u x0 y0 plus I into, again we have vx0 plus delta x plus x0 plus delta x comma y0 plus delta y. Here we have y0 plus delta y minus vx0 y0. Here we have the brackets. as the derivative f dash z naught is equal to, we can write f dash z naught is equal to as limit delta z tending to 0, delta z tending to 0, delta w by delta z exists. This exists. We then have f dash z naught is equal to limit delta x delta y tending to 0 0, real part of delta w by delta z, that is we can write f dash of z naught, which is equal to limit delta x delta y tending to 0 0, delta x delta y tending to 0 0, real part of delta w by delta z plus I limit delta x delta y tending to 0 0, imaginary part of delta w by delta z. Here we have imaginary part. This is equation, next equation number is 4. This is, here we have real part, here we have imaginary part. That is, we have a figure, here we have, this is our delta x, and of course this is our delta y. Here we have 0 delta y, here we have delta x 0. Of course this is our origin 0 0. Now it is to be noted that expression 4 is valid as delta x delta y tending to 0 0 in any manner that we may choose. In particular, we let delta x delta y tending to 0 0 horizontally through the point delta x 0 as indicated in this figure. This means that delta y is equal to 0, and the quotient delta w by delta z becomes delta w by delta z is equal to u into x0 plus delta x y0 minus u x0 y0 by delta x. That is, delta w by delta z becomes, which is equal to u x naught plus delta x comma y naught, u x naught plus delta x, here we have plus delta x y naught minus u x naught y naught whole divided by delta x plus I into v of x naught plus delta x y naught minus v of x naught y naught whole divided by delta x. Thus, limit delta x delta y tending to 0 0, we have real part of delta w by delta z is equal to, that is, limit delta x delta y tending to 0 0. Here we have delta x and delta y which tend to 0 0. Delta w by delta z becomes, sorry, it is real part of, that is, limit delta x delta y tending to 0 0 real part of delta w delta z, which is equal to limit delta x tending to 0, which is equal to limit only delta x tending to 0 u x naught plus delta x y naught u x naught plus delta x y naught minus u x naught y naught by delta x. Here we have delta x tending to 0. which is equal to ux x naught y naught. And again limit delta x delta y tending to 0 0, imaginary part of delta w by delta z becomes limit delta x delta y tending to 0. Next we have imaginary part of delta w by delta z. This becomes limit delta x tending to 0, limit delta x tending to 0. Here we have imaginary part, so we have v x naught plus delta x y naught minus v x naught y naught by delta x, which is equal to vx of x naught y naught, where ux of x naught y naught and vx of x naught y naught denote the first order partial derivative with respect to x of the functions u and v respectively at x naught y naught. Substituting these values in equation number 4, we find that f dash z naught, we can write this f dash z naught is equal to ux x naught y naught plus ivx x naught y naught, equation number 5. Now we let delta z tend to the origin 0 0 vertically through the points 0 delta y. This means that delta x is equal to 0 and the quotient delta w by delta z becomes that we can write delta w by delta z becomes u x naught y naught plus delta y naught, delta y naught plus delta y minus u x naught y naught whole divided by what we have the I delta y plus next term we have plus I into v, next term we have I into v x naught comma y naught plus delta y minus v x naught y naught divided by I delta y. This I can write as which is equal to v x naught y naught plus delta y minus v x naught y naught minus I into u x naught y naught plus delta y minus u x naught y naught by delta y. Thus limit delta x delta y tending to 0 0, that is limit delta x delta y tending to 0 0, real part of delta w by delta z, which I can write which is equal to limit delta y tending to 0, first term I have v of x naught y naught plus delta y minus v of x naught y naught by delta y. This is equal to what? Vy of x naught y naught. And also limit delta x delta y tending to 0 0, what about imaginary delta w by delta z? That is limit delta x delta y tending to 0 0, imaginary part of delta w by delta z, which I can write as which is equal to minus, here we have negative sign, limit delta y tending to 0 u x naught y naught plus delta y minus u x naught y naught by delta y, which is equal to, which I can write as, which is equal to minus u y of x naught y naught. Hence, it follows from the expression 4 that f dash of z naught is equal to, I can write f dash of z naught, which is equal to vy x naught y naught minus I into uy x naught y naught. Mark it as equation number 6. Here we have negative symbol. As LHS of 5 and 6 are the same, it follows by equating real and imaginary parts that ux x naught y naught is equal to vy x naught y naught. That is ux x naught y naught, which is equal to vy x naught y naught and also uy x naught y naught is equal to minus vx x naught y naught. Mark it as equation number 7. Here completes the proof. Next example, it's verify the Cauchy-Riemann equation for the function fz is equal to z square, and using our formula number 3, we have to find its derivative. The question is fz is equal to z square. If n is a positive integer, we have d by dz of z raised to n is equal to n z raised to n minus 1, that we have already studied. Hence, in particular, the function f defined by fz is equal to z square is differentiable everywhere, and f dash z is equal to 2z. Hence, the theorem is applicable. To verify that the Cauchy-Riemann equations are satisfied everywhere, we note that fz is equal to z square can be written as, this can be written as x plus iy whole square, which is equal to x square minus y square plus I into 2xy. Here uxy is equal to x square minus y square, this one is uxy, and vxy is equal to 2xy. Thus uxxy is equal to, we can write dou u by dou x, dou u by dou x is equal to 2x, and of course vx of xy, that is dou v by dou x, dou v by dou x is equal to 2y, and also uy of xy, that is dou u by dou y, this dou u by dou y, which is equal to minus 2y, and again we have dou v by dou y, that is here dou v by dou y, that is equal to 2x. Hence we have ux is equal to vy, ux is equal to vy, and uy is equal to minus vx. Hence, Cauchy-Riemann equations are satisfied everywhere. Also, by formula given by 3, at any point z, we can write f dash z f dash is equal to ux xy plus ux xy plus I vx xy which is equal to 2x plus I 2y, taking 2 outside we can write 2 into x plus iy, or you can write this x plus iy, we know it is set, so it is 2 set. Next we have locating points at which f has no derivative. Since the Cauchy-Riemann equations are necessary conditions for the existence of the derivative of a function f at a point z0, they can be often be used to locate points at which f does not have a derivative. So, next we have an example to discuss the non-differentiability of the function f z is equal to mod z square at z not equal to 0 using Cauchy-Riemann equations. That is f z is equal to mod z square. Taking z is equal to x plus iy. That is, so we have f z is equal to x plus iy, we have f z is equal to what? Mod z square. So it is mod x plus iy whole square. Or you can write this is equal to x square plus y square plus I0. We have uxy is equal to, here our uxy is equal to x square plus y square. So what about vxy? It is of course 0. So next we have to find ux, vx, uy and vy. So ux here is, that is ux means dou u by dou x, which is equal to 2x. Vx is equal to, of course, which is equal to 0. Uy is equal to 2y. And here we have vy is equal to 0. If the Cauchy-Riemann equations are to be held at a point xy, then we must have ux is equal to vy. We must have ux is equal to vy and uy is equal to minus vx. So that 2x is equal to 0 and 2y is equal to 0, which implies that x is equal to, here we have, which implies x is equal to 0, y is equal to 0. Hence, the Cauchy-Riemann equations are satisfied only at the origin. Consequently, f dash z does not exist at any non-zero point. This theorem 1 does not ensure the existence of f dash 0 for the function in the previous example. To ensure this, we need sufficient theorem. Due to the importance of the examples, we will consider it again. Next is sufficient conditions for differentiability. Satisfaction of the Cauchy-Riemann equations at a point z not equal to x naught y naught is not sufficient to ensure the existence of the derivative of the function f z at that point. But with certain continuity conditions, we have the following useful theorem. That is Cauchy-Riemann condition sufficient part. Let the function f z is equal to uxy plus ivxy be defined throughout some epsilon neighborhood of a point z0, which is equal to x naught plus iy naught, and suppose that first one, the first order partial derivatives of the functions u and v with respect to x and y exist everywhere in that neighborhood. And second one, those partial derivatives are continuous at x naught y naught. and satisfy Cauchy-Riemann equations, ux is equal to Vy and Uy is equal to minus Vx at x naught y naught. Then f dash z naught exist, f dash z naught exist, and its value is f dash z naught is equal to what we have, ux x naught y naught plus I Vx x naught y naught. So we will move to the proof. We assume that conditions A and B in this hypothesis are satisfied and write delta z is equal to delta x plus I delta y, where 0 less than mod delta z less than epsilon, and also delta w is equal to f of, that we know, f of z naught plus delta z minus f of z naught. Thus we have delta w is equal to delta u plus I delta v. This we can mark it as equation number 11, next equation number 11, where delta u is equal to, this delta u is equal to u x naught plus delta x y naught plus delta y minus u x naught y naught. This is our delta u, and of course delta v is equal to v x naught plus delta x comma y naught plus delta y minus what, v x naught y naught. Now in view of the continuity of the first order partial derivatives of u and v at the point x naught y naught, delta u is equal to ux x naught y naught into delta x plus uy x naught y naught into delta y plus epsilon 1 into delta x plus epsilon 2 into delta y. That I can write. That is delta u into ux into x naught y naught into delta x plus uy into x naught y naught into delta y plus epsilon 1 into delta x plus epsilon 2 into delta y. Equation number 12. And we have delta v is equal to, similarly we have delta v is equal to vx into x naught y naught into delta x plus vy into x naught y naught into delta y plus epsilon 3 into delta x plus epsilon 4 into delta y. Mark it as equation number, next equation number 13, where epsilon 1, epsilon 2, epsilon 3 and epsilon 4 tend to 0 as delta x delta y approaches to 0 0 in the delta z plane. Substituting expressions this 12 and 13 into our previous equation number 11, we obtain delta w is equal to ux x naught y naught delta x plus uy x naught y naught delta y plus epsilon 1 into delta x plus epsilon 2 into delta y. This is our delta u. Plus, next term we have plus what? I into, next term we have Vx x naught y naught into delta x plus Vy x naught y naught into delta y plus epsilon 3 delta x plus epsilon 4 delta y. This I is common for this one. Mark it as equation number. Next equation number we have 14. Assuming that the Cauchy-Riemann equations are established at x naught y naught, we can replace uy x naught y naught by minus vx x naught y naught and vy x naught y naught by ux x naught y naught. Equation number 14. And we obtain, by replacing this, we can obtain delta w is equal to ux x naught y naught into wx plus, instead of uy we can write minus vx. This minus vx x naught y naught into delta y plus epsilon 1 delta x plus epsilon 2 delta y plus I into Vx x naught y naught into delta x plus, instead of Vy I can replace it as Ux. X naught y naught delta y, the same one, epsilon 3 delta x plus epsilon 4 delta y. Okay. That is, I can write delta w is equal to ux x naught y naught ux x naught y naught delta x plus I delta y next one plus I into, I am combining this, plus I into Vx into x naught, Vx of x naught y naught. The remaining term is x naught delta x plus I delta y plus the other terms plus what? We have epsilon 1 plus I epsilon 2 delta x plus here we have epsilon 1 plus epsilon 3 here. For delta x we have epsilon 1 and epsilon 3 plus epsilon 2 plus I epsilon 4 delta y by combining this and this. That is epsilon 2 plus I epsilon 4 delta y. Now dividing throughout by delta set, that is delta x plus I delta y. The above gives delta w by delta z is equal to that is I am going to dividing throughout with a delta set. This equation becomes delta w by delta z. In the LHS we have divided by delta z, which is equal to ux x naught y naught plus I Vx x naught y naught plus epsilon 1 plus I epsilon 3 epsilon 1 plus I epsilon 3 delta x by delta z plus what remains, the epsilon 2 plus I epsilon 4 into delta y by delta z. Mark it as equation number 15. Now noting that modulus of delta x less than or equal to modulus of that is modulus of delta x less than or equal to modulus of delta z, and also modulus of delta y, here it is also less than or equal to modulus of delta z. We have mod delta x by delta z less than or equal to 1 and mod delta y by delta z less than or equal to 1. Hence, this modulus of, by using that modulus of epsilon 1 plus I epsilon 3 into delta x by delta z, which is less than or equal to, this is less than or equal to 1. So, I can write this is less than or equal to mod epsilon 1 plus I epsilon 3, which is again less than or equal to mod epsilon 1 plus mod epsilon 3. And similarly, we have this modulus of epsilon 2 plus I epsilon 4 into delta y by delta z. Again we have delta y by delta z is less than or equal to 1. This I can write as this is less than or equal to modulus of epsilon 2 plus I epsilon 4, which is again less than or equal to mod epsilon 2 less than or equal to, sorry, here we have plus mod epsilon 4. So, the last two terms of the right in equation number 15 tends to 0 as the variable delta z is equal to delta x plus I delta y tends to 0. This means that the limit of the left hand side of equation number 15, this limit exists, and that f dash z naught is equal to ux x naught y naught plus I vx x naught y naught. That is, we can write f dash z naught is equal to ux x naught y naught plus iv x naught y naught, ivx x naught y naught. Now, this completes the proof. Next, we have an example. We now examine the differentiability of the function f given by fz is equal to e raised to x cos y plus I sin y. That is, fz is equal to, here it is somewhat different, e raised to x into cos y plus I sin y. Where y is taken in radians and cos y and sin y are evaluated. Here u is equal to e raised to x cos y, v is equal to e raised to x sin y. This is our u, and v is equal to what? E raised to x sin y. Then dou u by dou x is equal to e raised to x into cos y itself. Dou u by dou x is equal to, differentiating we have, which is equal to e raised to x into cos y itself. Similarly, dou u by dou y, that is dou u by dou y, here it is e raised to x into cos y, so dou u by dou y, which is equal to minus e raised to x sin y, minus e raised to x sin y. Now, dou v by dou x is equal to, no change, e raised to x sin y, and dou v by dou y is equal to e raised to x into cos y. Hence, here dou u by dou x is equal to dou v by dou y, and dou u by dou y is equal to minus dou v by dou x. And this verifies the Cauchy-Riemann equations. Also, the first order partial derivatives are everywhere continuous and hence all the conditions in theorem are satisfied at all points in the complex plane. Thus, f dash z exists everywhere, and using equation number 16 we can write f dash z is equal to f dash z is equal to ux plus ivx. Which is again I can write which is equal to e raised to x into cos y. That is our ux is e raised to x into cos y plus I into e raised to x into, we have vy is equal to e raised to x into sin y, which is equal to, we can take e raised to x outside, that is e raised to x into cos y plus I sin y. In this example, we note that f dash z is equal to f z. Here we have f dash z is equal to what? F z itself. Next we examine the differentiability at the origin of the function f given by f z is equal to mod z square. Next example. We have seen in an earlier example that for the given function the Cauchy-Riemann equations are satisfied only at the origin. Also, the first order partial derivatives are continuous at the origin, and hence all the conditions in the theorem are satisfied at the point 0, 0. Hence, f dash z exists at z is equal to 0. Also, f dash 0 is equal to, we can write f dash 0 is equal to ux, that is at x at the point 0, 0 plus ivx at the point 0, 0, which is equal to what? 0 plus I0. For the function in the previous example, the Cauchy-Riemann equations are satisfied only at the origin, and hence derivative of the given function does not exist a point other than the origin. So here we discuss Cauchy-Riemann equations in detail, and we have done so many examples. Next we will discuss about Cauchy-Riemann equations in polar coordinates. Till then, take care.